Hello everyone. Today we are at Azure OpenDev. This program is totally not going to suck. It's completely live, which means you get to see me mess up in real time. I am starting out with my journey to Go, which is really interesting because I get to drone on a lot about myself and open source. So a little bit about me. I spent most of my life outside of the United States, and I also come from a long line of ninjas, apparently. My dad was a network engineer for NATO, which means that computers were always a part of my life. And I always had the best gaming computer. No, really, I really did. Fight me. Dune was always at my house. I used to build with my dad's spare parts because my dad always had the latest and the greatest. So that was cool for me. But sadly, I was a girl in the 90s, which means that I got to play with Barbies because girls didn't do computers in the 90s. It just didn't happen. My parents said, Ashley, you have an artistic brain. Computers are fun, but you should do something else. So I grew up and I became a photographer. I did that for about 10 years. And during that process, I realized a couple of things. You can't just go out and take pictures. You need a website. So I learned HTML and CSS and built a website. I needed a blog, so I built a blog. I needed to rank on Google, so I learned SEO. Everything was self-taught. It was really hard, but it was also a lot of fun. What happened, though, is that I learned that photography clients were not my target market. Photographers and other businesses were. Turns out nobody knew how to build a website. And just like that, I was a consultant because everyone needed a website. I was building websites for photographers, for hair salons, and then eventually I found myself doing a consulting job at Cisco. So I quit photography. Because what's the difference between art and pizza? A pizza can feed a family of 4, and art can't, just so you know. So I made a decision to code. While front-end development is still development, I wanted to do more. I was 32 years old when I learned to code. That is old AF, as the kids say. During that time at Cisco, I found a couple of small open source projects, OpenStack and OpenShift, and I was contributing, doing documentation for OpenStack and some front-end work for OpenShift. I found that I really liked the tech community. It was really inclusive at the time. And so I started contributing, but I wanted to make even more meaningful contributions. But I didn't know where to start. How was I going to learn? Everything in OpenStack was in Python. How was I going to do that? So you know, like when you go to a boot camp and you super regret it? So I'm going to bag on boot camps a little bit. Sorry, you people who went to boot camps. It's not your fault. In 12 weeks a boot camp says they will teach you the following things. I'm not going to read it all to you because it's a very long list, but I'm just going to scroll through these really quick. Week 1, 2, and 3. This is an incredible list, you guys. 4, 5, 6, and 7. In 12 weeks, you are learning all of these things. That's not impossible. It's impossible. And just like that, you're a software engineer. They give you a card, and it says, Ashley, you are a software engineer. And I said, I am not a software engineer. I've been in this long enough to know what a software engineer is. So I made it my mission to teach new developers how to get in to developing on their own. I created this Introduction to Programming resources. It's really great. A lot of it's free. Turns out these boot camps just teach you what's in these books for free. But I do understand that a lot of people feel like they need accountability of a class. So there's lots of people out there who are willing to mentor you or sponsor you. There's a really great blog post by Laura Hagen. Just Google it, mentorship versus sponsorship, and you should find it. It's great. So now we get to Go. I am an accidental gopher. I was writing Python, and I found myself at OSCON in 2015-ish, and I met Steve Francia. Steve Francia is well known in the Docker and Go communities. He is now in the Go team at Google. And he said, Ashley, I've known you for 5 minutes. Will you teach a Go workshop with me? And I was like, that is the dumbest thing I've ever heard, Steve. Why on earth would I do that? I've not even written a hello world in Go. And he explained to me that he has a hard time relating to the new developer. He's been doing it for a really long time. So it was my job to ask all of the stupid questions, and I did a really great job of asking stupid questions. So we decided to do this workshop at OSCON, and as you can see, it was pretty decently rated, which is strange because I had no idea what I was doing. In fact, I didn't know what I was doing the second time we did it or the third time we did it. And since then, we've given the workshop 5 times in 3 different countries, and I finally understand it, and I know what I'm doing. It took a long time. Lesson here, sometimes, I want to caveat sometimes, is just say yes. What's the worst that could happen? You could end up in front of 200 people talking about something you have no idea what you're talking about. But at the end, you might learn something. And also, nobody succeeds alone. None of you have. I am lucky enough to have a lot of people invested in my success. This is just a short list of those people. So thank you, all of the people on this list, for helping me and answering my dumb questions. So now we're going to get to contributing and eliminating excuses. See live. I'm not a very good programmer. These are all my excuses, but I've actually heard some of these from you too. I don't have a lot of time. My favorite one, I don't know what project to work on. This one I hear a lot. Myth, you have to be a programming wizard to contribute to open source. This is a really damaging thing to say, especially to newbies. There are lots of things that you can contribute to in open source. Open source is a community of people just doing what needs to get done. It's not always code. There are lots of things that you can do. So a couple of things. One, we need people of all skill levels. The wizards are great, but we also need the people like me asking the silly questions, because if you don't understand it, it's likely somebody else doesn't either. Small contribution is better than no contribution. Fix the docs. Like, fix some grammar. Somebody needs to do that. The best project to start with is the one that you're working with right now. So, here are some other things that I can talk about. Strengths, start with what you're good at right now. I don't suck at graphic design. Go has a really cute mascot. It's a gopher. That's why we're called gophers, made by Renee French. So I made lots and lots of gophers for lots of small projects in the Go community. Eventually, it got so overwhelming that I decided to make a website called gopherize.me with my friend Matt Ryer. Shout out Matt Ryer. It's an avatar generator, and it turns out that silly contribution had a lot more impact than I expected. InfluxDB uses it as their class photo. It's crazy. Not only that, people are using the API in new and interesting ways, and also making cakes. Somebody made a cake. That's crazy. This repo is just full of Gopher images. That's all it is. It has 772 stars. That's not insignificant. At least I don't think it is. I don't have that many followers on GitHub. So how did I know that Gophers, these little Gopher images were needed? I didn't really, if I'm going to be honest. But the best way that you can know what to do with your community is to start by listening. Everything in open source involves other people. You're looking to join a team. So shh, we're listening. Mailing list. This is a big one. So for many projects, a mailing list is the main conduit of communication. You're going to find out lots of things that the project needs. Start there. IRC and Reddit, that's where the people who are contributing to the project complain about things, figure out what they're complaining about, and see what you can fix. Blogs. Most of your heroes and core contributors have a blog. Read it. Working with tickets. Please work with tickets. Please do that. There's lots of bugs in open source. Diagnose a bug. Let's do that. They're often poorly reported. Please diagnose a bug. Close fixed bugs. Sometimes fixed bugs just sit there. They just sit there. Clean it up. It saves developers time. Please do that. That would be cool. And working with code. We all know that code is what makes open source happen, right? So let's talk about that really quick. Test. Beta test. Please do that. Projects run on many, many platforms. Test it out. See what happens. If it breaks, report it. I can't emphasize this enough. Fix a bug. This is where lots of people get started in open source. Fixing small things. Eventually that adds up. Write a test. More tests, please. You can't have too many tests, in my opinion. Some might argue. Don't do that. Add a comment. As I said earlier, if you are confused, somebody else is too. Docs. Please, please, please help with the docs. Oftentimes, documentation is written from the point of view of somebody who's actually writing that project. It can seem like a manual. So somebody new coming in has a different perspective. So help with that. It's important. It might seem tedious, because it is, but it's important. Work with the community. Open source is all about the community. Answer a question. That's the best way to build people up. Answer my dumb questions, please. Write a blog post. If you find a bug and you fix a bug, or you're using the project in an interesting way, blog about it. Tell people what you're doing with it. Improve a website. Sorry, most programmers don't have a lot of design talent, and that's okay. But more than anything, pay it forward. If you're using a project and you're not contributing, shame on you. I feel like a hypocrite with this quote. Don't be too proud to accept help when it's offered. I often am too proud to accept help when it's offered. However, I never regret it when I do. Also, it's okay to fail. I do literally all the time. If anyone says that they don't, they're liars. Lying, lying, liars. And more than anything, we are a community of coders, but if all we do is code, then we've lost the community. Thank you. I am Ashley McNamara, and off to my beautiful co-host, Seth.
How's it going, everybody? My name is Seth Juarez, and as you know, open source, the reason why I love Ashley's talk is because it talks about contributing and how to actually contribute. And I'm here with Ryan Parks, who actually is from the place where a lot of contribution happens. Why don't you introduce yourself a little bit, my friend?
I am. So yes, thank you, Seth. I'm Ryan Parks. I'm a solutions engineer at GitHub. So I've been there about 3 years. And my role is basically making sure that people know how to use GitHub, helping them use GitHub, helping companies change how they make software. So it's very much in line with the themes that Ashley was talking about.
So in the context of open source, though, GitHub has taken off. Why do you think that is?
I think it's because it offered a different and new way of working together that excited people and captured their imagination. That's certainly why I was attracted to GitHub and why I started using it before I worked there. So
my horror story, every dev has this horror story. I was using this automated tool, and I automatically wrote some stuff to a directory, and it deleted all my source code. This was like 8 years ago. And it was at that moment that I decided it's time to use source control. So if you're not using source control, shame on you. You're going to be like me, and that code is still actually out there, and I can't fix it ever because I don't have it unless I rewrite it.
Yeah.
But GitHub is different than source control. It has source control, but there's a little bit more special sauce. Why don't you tell us about that, and then tell us a little bit about how one would use these workflows, these open source workflows in the enterprise?
Sure. Yeah. So I'm going to be talking about something that we call inner sourcing today. That's going to be the topic of my talk today. And I have a few slides. It's not too many. I promise it won't bore anyone. But I want to talk a little bit about why I chose this topic to talk about. And the way I like to start off a lot of talks like this when I don't know how to start is with a question. Maybe you're familiar with this. And so this is kind of a thought experiment for everybody watching, for us. And the question is, what's the most challenging part of developing software in an organization? And I think at least part of the answer to that is communication, right? Communicating what we're working on, right? Communicating that what you've just done, what you're going to do, is extremely important, right? And we need tools that help us do that. Because there's more communication going on today and more software developers today using more tools today than there ever have been in the past. So there's more communication, and we need tools that allow us to do that in a sane way, right? And I think a kind of humorous illustration of this need is this slide from the Cloud Native Computing Foundation, which I find, in a way, it's kind of funny because it attempts to capture the landscape of all the different tools that we might use today as developers. And you might need a magnifying glass to figure out what's actually going on in all of these. And my basic point is just that there are so many tools that we use today. There's a proliferation of different tools, and they all require that we know what's going on at some level. Like different teams are all using these different tools, and they're all trying to work together. But what we need is actually not just another tool to communicate. So I made this slide because I wanted to illustrate that it's not just about adding another tool. Adding another tool may make this picture more complicated, but it doesn't necessarily help you do anything better, right? I think we've all worked at places that had all of the right tools, but none of the right processes, right? So it's not just about what you're using. And that brings me to why I chose to talk about inner sourcing, because I think it's a great illustration of the principle of not just being about tools, but also being about how you use the tools, the process by which you use them, okay? And inner source, just to quickly define it, if anybody's not familiar, it's a little bit, it's a newer concept, but it's certainly not something that folks wouldn't be familiar with. So it's merely the idea of taking successful and productive practices from the open source world and applying them inside of your own company, right? And that could be 1,000 different specific things, but it's just the idea of looking at projects that you might use on GitHub today, right? That you contribute to today, that are doing things that are encouraging people to contribute, or something that's really cool that you could be using inside of your company.
So let me see if I understand this, because I looked at inner source and I was thinking, oh, is this another picture we're going to add to that whole picture of development? It's not. You're saying these are ideas that have been taken from successful open source projects, and because there's a lot of them.
Yes.
And you've watched them because you work at GitHub. You've watched them, and you're saying here are some of the principles that they use in order to make their open source project successful on GitHub. And you're going to explain like what those are. I mean, I have an open source project, and I feel like it's far from successful because of some of the issues with communication, as you mentioned.
Yes, so I'm going to be talking about a few of those ideas and how you can start applying those to your organization. And the critical thing is that it's all about studying what works in open source and applying that, mapping that into your organization. So it's not about taking exactly what folks do in the open source world. It doesn't always translate into how things are done in a company. And that can be good and it can be bad. So there are trade-offs there. But it's about applying those specific principles. So that's why I'd like to make sure that people come away with today with an idea and some inspiration to actually go out there and look at how their organization works and think about some of these ideas around communication and how they're using tools and building processes. Because effective communication, I'll say that doesn't happen by accident. Right? It takes a lot of intention and planning to make sure that you're in the right environment to do that.
All right, well, I want to dig into the principles here.
Yeah. So just quickly, I'll just show this slide of why InnerSource. I think we've covered a lot of this, and I don't need to belabor the point here. But this is basically just a rundown of why you'd want to do this, right? More contributions, more quickly, higher quality. So it's doing more with less. And just a really quick example of this that folks can go check out. This is a graph from Illyriad Games. They worked on Age of Ascent. So the team there radically improved the performance of .NET Core over the course of a few months. They actually got a cake from the .NET team. They did such a good job. But I just wanted to throw this out there as an example of what is possible when you open up what people are able to contribute to your projects, right? So I'm not promising that all of your projects are going to be 2,300% faster. No, that's not going to happen. But I can say that this is the potential. So there is an Illyriad Games within all of the companies that we work at that can be unlocked. It's just about setting up the right success, the right environment for success.
Got it.
Yeah. Cool. So, I have one more slide. I think this is the ultimate payoff. Like, this is why folks should care about inner sourcing and DevOps, right? So DevOps, I saw a really cool definition of DevOps, that it's something that accelerates your ability to deliver applications and services, right? And by that definition, the practices that you apply with open source definitely fall under that. And we can see where those overlap with this, it's a very cool developer enjoying a nice drink under a shady tree, right? So this is the idea. This is why I think this is exciting for developers, because it has the potential to make your life better.
Yeah, anything that improves my practice of communicating, because literally all software is a communication problem.
Mm-hmm. Yes.
I've had many software failures, and they all come down to I understood the things wrong. Mm-hmm. And so I'm excited for any principles you have on how to make this better.
Awesome. Yeah. So that's all my slides. So hopefully that set the stage for what I'm going to be talking about within my demo here. So why don't we dive in?
Let's do it.
Cool. So this is my GitHub organization. This is often the first place that folks will see, and you can see I have a few repositories that have been created in here. So the repository that we're going to be looking at in a couple minutes is this Java calculator repository, and you can see a couple others that I just put up for fun. Elk Terraform, Java calculator that's powered by a Habitat. So just a shout out to our other presenters today. These aren't real working examples, but this might be in an organization. So the first thing that I want to point out is the different visibility levels of repositories. So there's private and public repositories. And that's the most basic level of visibility control that you can have. So if you want everyone to be able to see your project and contribute to it, public is good. If you want to control who can access it through teams, private. And I'm using a GitHub Enterprise instance, so I can control who is able to access this URL. So folks need to sign in before they can look at anything. So it's actually okay for me to keep things public. It just means that they're public to my organization.
Got it.
In OctoDemo. In GitHub.com, the situation's a little bit different. If you want to keep something private, so if a company wants to keep a project private on GitHub.com, it has to be private, right?
Awesome.
So anything on GitHub.com that's public is open to the world.
So this enterprise is just an instance of the software that you have running as a demo purposes.
That's right.
By the way, for those that are watching, please make sure if you have any questions, use hashtag Azure OpenDev. We are monitoring the questions, and so we want to hear what you have to say as well.
Absolutely. Yeah, thank you. That's right. Where was I?
You were in the middle of saying that on GitHub, the situation is a little bit different.
Yes.
Because if you want something to be private, it has to be
Yes.
private.
Yes.
Here, it's a situation where it's kind of private to all of your organization, but then you can make things private for a subset of your organization as well.
Exactly. Yeah, so if people who are watching were to go to octodemo.com, they would have to log in. They wouldn't be able to see this. So something to note with the visibility of repositories. And then one thing that I'd like to point out within an organization, beyond the repository visibility, is the default member or the default repository permissions for members. So by default, you can set certain levels of access for organization members. In very open organizations, this might be set to write. So everybody that's added to the organization can write to all of the repositories. And that can be a really powerful model for collaboration, right? So everybody by default can write to things, but it can also be dangerous. Read, similar situation. Everybody gets read access to every repository, whether it's public or private. Typically, organizations choose none. That gives you the most control over what folks are able to see. So that's usually what folks go with. So that's default repository permissions. And I also want to show teams here as well. So teams are how you organize access to your repositories. So they're very important. And I think it's worth spending a little bit of time explain something a little bit newer. So you can see there's a few teams listed here. So there's a couple secret teams, which I'll talk about in a moment. And then there's this employees team with this tab here, and then a few other teams. So the first thing that I want to show is this nested team. So nested teams are something we introduced recently that can help you organize, or rather, put folks into more logical groupings in terms of your teams. So you can see I expanded the parent and child teams here to show what's actually going on. And what's great about organizing your members in this way is that if I wanted to give read access to or write access to a certain repository to all employees, so let me just open a new tab and do that. So if I wanted to change the ability of all of the people in the employees team to write, I would just have to change that in one place. So it's much simpler than going to a dozen different teams and assigning them. It allows you to cascade all of those permissions down, right?
And this is in enterprise edition. Is this something you can do in the public one as well in GitHub?
This is in github.com and GitHub Enterprise.
Oh, I did not know that.
Yes.
That's amazing.
Yeah.
I mean, this is a really powerful way of just organizing people.
Yeah. So it allows you to reflect your organization to the extent that it makes sense inside of GitHub.
I see.
So rather than having multiple organizations, which can definitely make collaboration more difficult and visibility harder, you can have a single organization with nested teams that reflect your engineering structure, typically, since that's who is mostly dealing with GitHub.
And that goes back to the notion of communication, because
Yes.
if you have to communicate with two people, there's just one line. If it's three, then there's 3 lines, or 4, or 6, right? There's choose 2 lines of communication. If you start to break up like where people naturally communicate into teams, that makes the communication a little bit easier as well.
Yes.
Cool.
Yes, and the layout of the teams, I think it's hard to understate how important the teams and their structure become to how people are able to access repositories that are owned by the organization. So, and this is what I was referring to when I was talking about taking a lot of thought and foresight and planning. Many organizations grow organically without people thinking about, well, who should have access to this? So I think it's important to plan that out, so you can actually say, well, maybe why don't all our engineers have access to this project, like our main code base,
Right.
for example? Everybody should have access to that. But I think the concern with that kind of model is what is possible. Like, what are the downsides that we open ourselves up to by allowing that kind of creativity? And that's why I'm going to show inside of the repository.
Cool.
So how you can open it up to more collaboration without compromising the quality or making sure that people don't overwrite the history of the repository, for example.
Yeah, I have. There's some things on GitHub that I've done with Git in general, where I'm just like, I think I just destroyed everything, but I hope not. Yeah. So so it's better to be safe about those kind of things too.
Yes. Yeah. Absolutely. So really quickly, I just want to talk about these other teams. So we looked at this employees nested team, and I just want to show you 2 other types of teams. So there's this secret team, and a secret team can only be seen or mentioned by members of that team, right? So other people in the organization that aren't members, so anybody who's not Ryan or Kylo, don't know about 007, the team, and nobody outside of that team can mention it. So this can be great if you have projects that are sensitive, if you have contractors, whatever the case may be, where you want to isolate the visibility and access that other people have to that team. So those are secret teams, and I have another secret team that's just for bots. And the 3 teams at the end, I just want to mention as this is something a colleague of mine, Greg Paddock, referred to as ad hoc teams, right? So there's the official organization of your company, and then there's what people are actually interested in, or what they're experts in within that. And this is what teams and ad hoc teams in GitHub are great for. So I have a few here. One for Node.js enthusiasts. And what's really cool about this is that this cuts across all of the different cross-division and cross-department areas that we have. So there are people from different teams within, or rather from different engineering groups within technology, who are all part of this Node.js team. So it cuts across different silos and allows you to create places where you have concentrated knowledge on Seinfeld, maybe not as useful, or sweet potatoes, or Node.js.
And that's
right?
interesting, because then when you have certain things that come up, Like if people are talking about, let's just say you're working on a certain feature and you're just like, hey, let me just tag the Node.js enthusiasts to come take a look at this. Can you tag them all at the same time and then have them comment on these things too?
Yeah, so if they're in a team, then you just mention the team, and they automatically become part of the conversation.
And that's awesome
so
because then you can have the functional teams, and then you can have the cross-cutting teams that can be brought in, as necessary, because obviously they have other work. But if they love Node.js, heck, let's just take a look at this particular issue that people are having in this other team. That's awesome.
Yep. So ad hoc teams, nested teams, secret teams. These are all the building blocks that you can use to make sure that folks have access to the right things within your organization. Cool. So with that, I'm actually going to go show the app that we're working on. So the repository I'm going to be demoing with is this Java calculator repository. So super complex code base. It can do all kinds of operations.
Sure.
Addition, subtraction.
Yeah, the main ones.
Yeah. And it also has a REST API. So this is a Java app that gets deployed out to an Azure app. And is running out there. So you can see I just have the ping endpoint over here. So yeah, this is my repository. So let's imagine for a moment that I just opened this repository up to everybody in the organization, right? I just added this to the employees team and gave everybody write permission. But now that that's happened, I'm getting kind of nervous. What if somebody deletes the last 50 commits and then force pushes it, or breaks the build and then that goes out to production? Like this is just being deployed out into production.
So it's CI/CD'd already, and so if people write to it, they might write something crazy.
Right now, there's no CI.
Okay.
So it's just whether it's broken, whether it's working, it's just going out there.
So not as
right
scary.
Well, it's continuously deploying failure, as the case may be. The issue is that right now I don't have any way of knowing I don't have any unit tests written in this repository right now, so I have no idea of whether anything's been broken or not.
Cool.
So I think the first thing that I want to point out in this repository is the existence of this README file. So this is really important. And you can see it's actually displayed down at the bottom here. If you've looked at a GitHub repository, I'm sure you've seen this before. And the README is really important because it's the entry point for people into your project. So this is usually the first thing that someone's going to look at. So it's important that after they look at this, that they know how to run the project, that they know where to look if they want to contribute something, if they find something wrong. And this is a good example of a README because it has that basic information there. So it has a description of what the project is at the top. And it also has a link to this contributing.md file, which I'll talk a little bit more about in a moment. But those are guidelines around if you want to open an issue or make a contribution, how do you go about that, right? And then it has all the instructions that you need to actually start building this and running it locally, right? So those are really important, great to have. And there's a few different files. They're kind of GitHub metadata files, I guess you could call them, stored in this repository that I want to talk about for a moment. So I already mentioned the contributing file. And this is important because it's a more detailed explanation of how you want people to contribute to your project. So it's aspirational. This is what an ideal issue that's opened would have. So you can see that this document directs people, where they can ask questions on Stack Overflow or IRC, how they can file issues, as well as a few guidelines around what they should have done before they actually file an issue. And then at the bottom, there's more details around what to do if you actually want to contribute. And I think at the end, this section on feedback is also great because it gives people an idea of what they should expect after they submit something. So it kind of paves the way for people to contribute and makes sure that there's no, or minimizes the amount of surprise or confusion that people go through in common paths.
So I have like a couple questions on this, because I'm looking at this and this is amazing. First of all, the .github file, is that a convention or the .github folder, is that a convention we should follow and just have those things in there?
So that's a convention that you can use to store these files. So let me just go back and show. So these are all files that have to do with GitHub specifically. So we make it easy to store those in a hidden folder in the repository that doesn't clutter things, but you can keep all of these in here. So they can live in the root of your repository. I like to keep them in a folder to keep them a little bit more organized.
Got it. And then the other question is, when we're talking about issue template and pull request template, those documents are just saying what you should do during a pull request, or does it help you create them, or what are those for?
Yeah, so I can show you what those actually do really quickly. So there's already an issue open about adding unit tests to the repository. We don't need to look at that right now. But here's where those templates actually come into play.
This is amazing.
Yeah, so this up at the top, you can see there's a link to the contributing guidelines that I was talking about earlier. And the issue template file that was in that .github folder has actually populated this entire issue with a template. And the markdown file is just that. It's just markdown. But you can see I actually used HTML comments in here as well. So Markdown supports HTML. So you can actually get pretty sophisticated with the formatting if you want to. But I just use it so I can provide instructions in the template without having that actually show up if people submit it without filling it out. But this is what you can do. So you can define all of the major areas that you want people to fill out. And then actually have that in the issue when it's open.
That's pretty amazing, because I usually get a lot of "it doesn't work," and I have no idea what they're talking about. This here, just in a social way, is saying, "Hey, look." And the thing I like about this is when you're creating an issue, like that is a contribution. And so I love how you say, before you open an issue, let's talk about what it means to contribute. Here's something that we would like to see. And socially, you're not hitting people over the head saying, well, you didn't tell me anything. Right? Beforehand, the computer's gently nudging people to communicate a little bit better, which I really like.
Yes. Yeah, it's removing some of the element of you needing to ask someone to do that and putting that in front of them so they know what to do.
I love it. Well, we have about 6 or 7 minutes. I want to cut you off, but this to me is probably one of the coolest things I've seen.
Yeah.
You already probably knew about this, but I didn't. And so if you're not using this, definitely we should start looking at it.
It's new for a lot of people, so don't feel bad if this is new. Cool. So since we only have about 5 or 6 minutes, I think I'm gonna skip ahead to showing a few of the protected branch settings. So how you can actually, how you can make sure that quality doesn't suffer, that people don't accidentally remove things when you're working in your repository. So the two options that I'm primarily concerned with, the first option is to protect the branch, right? So if you protect your master branch, let me go back one screen. So protected branches you can configure for any branch in your repository. Typically, people do that for their master branch,
Right.
since that's what's going out to production, what you're cutting releases from. So once you're protecting your master branch, which is the baseline for what you would like to do, that disables force pushing, so people can't alter the history of the Git repository, and they can't delete commits, which is a good start, right? But there's two other options that are also really important. So require pull request reviews before merging can be great for making sure that humans are actually looking at code before it's being submitted, right? So when somebody opens a pull request, they must have somebody else review it and approve it before they can actually submit it, right? So that's an excellent practice for encouraging code review because people have to do it, right?
Sure.
And there's a few options around here that make this either more flexible or more useful. I think the most interesting option is the require review from code owners. And that uses the code owners file, which I didn't have time to show. But it uses the code owners file to determine who to request for review. So let me just show the code owners file really quickly. So it's just either files or paths or wildcards in your repository, and then teams. And when you open a pull request, we look at what files have changed, and then we'll automatically request review from the right team, from the matching, from whatever matches we get from code owners.
I feel like I've been using GitHub wrong for many years. I mean, seriously, this is amazing.
This is also new, so again, don't feel bad if this is new.
No, I'll feel
new
bad
information.
because then I'll fix it, right? That's the best part.
So yeah, code owners are great. And the second thing that's really important is requiring status checks to pass before merging. So this allows you to actually kick out your, you build your repository in your CI system, and then the result of that build is sent back into GitHub, and it's displayed in the PR. So you can actually see, did the build pass or fail? And if it failed, it's actually not possible to merge in your pull request if a required status, so I have this second status here marked as required. If that doesn't return successfully from Jenkins, I will not be able to merge that, right? The merge button will not be available.
Right.
So that's how I keep contributions from breaking things. That's how you can put some guardrails around what folks are able to put into the repository.
Right.
Yep.
So we have about 2 more minutes. Can you do whirlwind through a couple of other things that we should look at?
So let me save this. This is actually going to be, let's see if I can show you this. So I have code open here. I'm going to clone my repository. I'm going to make a branch. And then I need my terminal. If only writing tests in the real world were this easy.
Right.
So I've added my tests, right? It's done.
Nice. I love the hand waving. Like he's literally waving his hands right now, but we didn't put that on because it looked ugly. Just no offense. Right.
I'm waving my hands all over the place. Thanks for telling everybody.
No, but this is good because I think the important part is I want to see how this actually goes into the workflow of what you're doing.
Yes. So I'm just committing this locally, and now I'm pushing it up to my branch. And I'm switching to another window where I'm logged in as just a normal developer, as Ryan. Cool. So I can actually see that this was pushed up. And you can see the PR template actually populated all of this. So let's create this so I can actually see what's going on. So really quickly, you can see that under the reviewers, the quality team was requested for review. And you can see because of the setting, my repository setting that I made, code owner review is actually required here. So I cannot merge this until somebody from the quality team says, all right, this looks good. And additionally, required status check has also failed. The test that I coded intentionally had a failure.
That's what you get for hand waving. I'm
Yep.
just saying.
I was waving with one hand and I typed a 5 instead of a 4. So you can also see that this red box merging is blocked because of that. So that's the 2-minute finale of all of that.
Oh, and that's amazing. So here's a couple of questions from the audience. As this is Azure OpenDev, what is an easy way to discover all of the Azure-related repositories on GitHub for searching and finding things? How do you do that?
So there's actually a lot of great Azure organizations out there. So if you can use the search qualifier for organizations and look for Azure, there's a lot of official Azure orgs out there. I would also check out topics. So similarly, if you use the search qualifier for topics, there are many repositories on GitHub that have been tagged with something called topics. So I actually have an example of that in the repository I have here. So topics are below the description of a repository, right? And these allow you, I can actually show you in GitHub what this might look like.
Oh, snap. I did.
Right.
I said, oh, snap. I'm so sorry, Ashley. I'm sorry.
So these are all the different repositories that have been tagged with Azure, right? So this is a cool way of exploring the different repositories that are out there on github.com. So there are about 1,200, so whoever asked that, they have a few things to look at now.
Awesome. Well, this has been amazing. Ryan Parks, we are going to be new BFFs. I'm going to be calling him at night being like, hey, help me.
You're getting a shirt.
It's
coming. It's on its
I'm
way.
going to put a shirt on it. He's giving me a shirt, okay? So it's official. We made it official. So coming up, we have continuous delivery of infrastructure to Azure with Tyler Croy. And take it away, Ashley. Well, before, we actually have an in-studio audience, but they've been so quiet. Like, I was hoping they would laugh just a little bit, at my dumb jokes. So we're really going for that. So just take a look at them. You can see them right there. All right, Ashley, toss it over to you, my friend.
So we already knew that you were terrible at GitHub, Seth. We already knew that. I just want to point out that I stole this hat from Tyler. I legit stole this hat. He says he has 200 more, which is great because I'm not giving it back. Also, I'm standing on a box. I'm standing on a box because
The guy
he's so
from the
much
control room came out and was
taller
like,
than me.
we should put this box in here.
Yeah,
We
so
should make sure
So you're welcome for that, yeah. Let's get into this. You don't have to squat now. We're all good. We're going to talk about Jenkins. Jenkins has been around for what, like 10 years? So
I've been in the project for a little over 8 or 9 years, maybe.
Okay.
And it existed a little bit before then. The creator, who's now my boss at CloudBees, Kosuke Kawaguchi, created it at Sun Microsystems in 2006. And
Yeah.
any sentence with Sun Microsystems is already a pretty old-timey thing to say at this point.
Right.
So it's been around for a while.
So it's old timey. So tell me
Folksy. It's folksy.
why we should all care about this now.
So one of the cool things about working on a project for this long, I think I've worked for 4 different companies now, and at each company I've brought Jenkins into that
Sure.
into that organization, with the exception of CloudBees, which does sort of enterprise Jenkins stuff. And the cool thing about working on a project for that long is it's become very, very well known, very well adopted. It's really actually funny to be in a Microsoft studio talking about a Jenkins project on my Linux laptop with Microsoft logos all over the place. Like, the world has changed dramatically since the project started, which is both really promising, but it's also really good for us because we've been able to help drive some of that change in the software industry. And what is really powerful about Jenkins is it's an automation server, sort of at its most basic level. It helps with automation, right? In the beginning, that really was continuous integration. Let's not dim out here. So continuous integration was sort of where Jenkins' bread and butter was. And as the industry moved on, like Jez Humboldt and a few other people started talking a lot about continuous delivery. The folks from IMVU started talking about continuous deployment even. And Jenkins has been able to adapt and grow with that because A, it's open source, and B, there's a lot of contributors that are bringing different plugins and integrations to Jenkins that make it sort of this like infinitely pluggable piece of automation technology that just about any organization can take and just drop into their existing infrastructure and make it work for them.
Right. We live in like a continuous everything world
Yeah.
right now,
Yeah.
which is great, I think. It's
And
great.
Jenkins helps with the continuous part.
Yeah.
Yeah. But it's something that, you know, as we've grown, the things that we did, I would say in 2006, aren't necessarily the things that we need in 2017.
Sure.
And so over the past couple of years, there's been a few sort of major leaps forward in what we do in the Jenkins project and how people use Jenkins. That is something that's for me, part of my day job is actually telling people like, no, Jenkins is different now. There's a lot new stuff there, a lot more new stuff rather, that is really, really interesting, really, really easy to use and really, you know, nice to look at.
We just bonded. 'Cause I do that at Microsoft too now. Yeah.
It was weird for me because when I first started with the project, I was, Kosuke would sometimes refer to me as the cheerleader.
Yeah.
Like my entry into the project for a long, long time was I would write stuff on blogs, I would write some documentation, I would go speak about it at events because Jenkins underneath all the covers was Java, and for me, you know, as a Python and Ruby developer, I found Java.
Gross? What?
I wasn't going to say gross, but I was thinking it. It's a little gross. I don't particularly like Java. Java 8, however, is actually quite nice. They've changed a lot in Java land. But so I came into this open source project that I really enjoyed using, like, what can I do?
Yes.
And the documentation stuff came along, some of the outreach type stuff came along, and the infrastructure stuff started to be an avenue that I started to contribute to the Jenkins project. When you have, in ye olden days before GitHub was around and sort of making everything awesome for people, people had to run servers to run their open source projects. It was
I
like
don't even remember what life was like before GitHub. How
it was.
people clicking stones together, crazy.
That's about what it was.
Yeah.
Yeah, it was. You took some SourceForge and some CVS and you tried to make things work. And so we had a lot of developers in the Jenkins project, but no one wanted to run the servers. Like no one wanted to run the infrastructure to make the project go. And so that's actually how I really started to get deeply embedded in the project, was someone had to keep the lights on, and I'm a gullible idiot, and I said, I'll do that. And so that's what I do with my colleague Olivier. We work on a lot of the infrastructure, which is what brings me to Microsoft and Azure.
Cool. Well, let's get into that.
Sure.
I know that you're gonna not demo things, but let's talk through this.
Right. So to sort of step back a little bit and so before I get to the infrastructure stuff, let's talk about Jenkins pipeline, which for me was one of the big leaps that we've made over the last couple years. In the old stone clapping together world of Jenkins, the way that people would construct their automation is they would go through this WYSIWYG editor and they would create a job configuration. And if you had something like my normal project, I've got to build it, I've got to test it, and then I've got to release it or deploy it somewhere.
Right.
Like most projects fit into that sort of build, test, deploy pipeline. So what people used to do is you would create a build job, you would create a test job, you'd create a deploy job, and you'd chain those together. And it was sort of, you could do it, and a lot of people did, but it wasn't very clear to people, users coming into the Jenkins interface, what was actually wired together, how
Right.
everything was configured. And so sometime before we released Jenkins 2 last year, a number of people within the project started working on this thing that we called pipeline. And Jenkins pipeline is sort of, I would say it's not like jobs in that the goal is to model your entire continuous delivery process, right? So instead of just doing the build stuff over here and doing the test stuff over here and the deploy stuff, let's put that all together because that's how we think about our software development lifecycle, right? So that was part of it. And then this sort of like X as code movement was also a big influence. Like I started using Puppet probably 5 or 6 years ago, and about 4 or 5 years ago, I started to get sick of the infrastructure as code sort of rhetoric. But with Jenkins, we had a very strong need for the pipeline to be defined as code. Like when we talk about using GitHub to sort of keep track of things, the one missing link for a lot of people was, how do I keep track of what Jenkins is supposed to do? Right? And so we created pipeline. We created. Yes, I helped create pipeline. I had nothing to do with it. I just like to talk about it and use it. But some people like Jesse Glick, Andrew Bayer, a lot of the, I would say, titans of the Jenkins open source project came together and built out what is today Jenkins pipeline, which is by far the best way to do things in Jenkins. I cannot, like if you're using Jenkins, this camera's on. If you're using Jenkins and you're not using Jenkins pipeline, you should be using Jenkins pipeline, full stop. It's flag in the ground. It's so much better than everything that was there before. I can't stress that enough. But it's also very simple. So on the screen, what I wanted to show was like the most simple declarative pipeline.
Right, so I wanted to ask a question about that. So there are 2 different ways to define pipelines, scripted versus declarative. So like, why would I use one over the other?
So there's a little bit of cultural tension in the Jenkins project. On the one side, you have people who are like, I want super awesome power tools where I can just do whatever the hell I want, whenever the hell I want.
Yeah.
That's what scripted pipeline is really for. Scripted pipeline is a subset of Groovy, which is a Java-based or JVM-based scripting language, and you can do just about anything. It's all sorts of banana stuff going on in scripted pipeline. The other part of the Jenkins project, and this is where some of the tension comes in, is like, I don't want to think. Don't make me think about stuff I don't need to think about. How can I do this as easily and as quickly as possible?
Yeah, that's me.
That is you.
Yeah.
So declarative pipeline is the pipeline for you. But they're both actually built on top of the same sort of underlying engine.
Okay.
So it's just sort of 2 ways to get into the same underlying core of stuff, right? And so what I have on the screen, this is actually a declarative pipeline.
Okay.
And so it's very, very simple, very basic. And there's not a lot of need for you to understand how Jenkins does everything. It should be fairly straightforward to understand, fairly straightforward for everybody in the project. So maybe you've got designers, you've got some coders, a product manager, some other ops people running around. Everybody should be able to understand that Jenkins file that gets checked into your repository because you're all collaborating on that software delivery process.
Right.
So if we look at this one in particular, it's pretty basic. I mean, instead of having build, test, deploy, I'm really just doing a build. And all it is saying, give me a Docker image that runs Maven, and then run the Maven.
So my eye went right to Docker. How long have you guys been running Docker in production?
So the Docker and Jenkins have sort of an interesting past. We started using Docker for our infrastructure probably 4 years ago because Kosuke said we should do this thing, and sometimes I have to make that leap of faith when Kosuke says something. And it turns out he was right. It was good for a number of reasons. But as the Jenkins...
You heard him. He said you were right.
Kosuke probably hears enough from me that he's wrong, so it's good to have on the record that he was right. But so we started using Docker a long, long time ago within the project itself. And when we started to develop pipeline, it became very clear that Docker as a sort of build and test execution environment was an ideal sort of thing to marry into Jenkins pipeline.
Right.
Because if you think about it, like most projects now, I would say if you start a project now, you've probably got some front-end stuff in Node.js, you probably got some back-end stuff in Python or Java or whatever, Go even. I hear people use Go a lot.
Yeah.
Some people out in the fringes use Go. Everybody else uses Java.
Getting off my bum, going home.
Shit, I'll have to do the rest myself. But you have these repositories and these applications that are being developed where it's not just one environment anymore. You've got multiple languages coming together. And that's where Docker and Jenkins start to really play well together. Because in your pipeline, like what we've got here, for my build of this application, I need Java. I need the JDK. I need to build that. for another stage of this pipeline, I might need Node.js. And instead of setting up my Jenkins environment to have versions of Java installed, versions of Node.js, and managing all of that complexity, instead what I can say is just use Docker and push that to the team that runs that application, and they can choose what the right things are for their application.
Very cool.
Which is one of the things that also makes pipeline something, whichever camera's on, something you should use like right now. Whether or not you deploy Docker into production, I think that's an important lifestyle choice. You should consult your operations team on whether that's a good fit for you. For us, it's definitely made life easier, but it's not for everybody. But inside of Jenkins, it makes a tremendous amount of sense. So if I could just jump over to like an even more sort of complex Jenkins pipeline. Imagine for a second you've got your sort of simple, I've got my pipeline that does some build stuff.
Right.
The nice thing about this being code is you can start to iterate on that, and you check all of your changes into code, or into the repository. So over time, you might find, I've now got some Node.js stuff in here. I'm going to add a stage to do Node.js, and that can be another revision. Or you might find, like this is a demo one of the guys that works on this Blue Ocean project, which I'll show you in a second, created. You might find you need to do a little bit more complex things like run browser tests in parallel branches for Firefox, Safari, Chrome, etc. That you can all start to code into your Jenkins file and do something really interesting with that. So I think what I would like to do is actually show you some of the Azure stuff that we've got going and the Blue Ocean stuff that we've got going. James Dumais, who's one of the folks that works on Blue Ocean, he really, really enjoys the color blue. So we try to give him as much grief as often as possible about his color choices, but he hasn't quite latched on to Azure yet. We've used all the other colors in the palette except for Azure. So because we're an open source project, all of our infrastructure and our code, our Jenkins files, our Terraform, our Puppet, the Java code, front-end code, all of that is open source on GitHub. But because we are the Jenkins project, we also use Jenkins very heavily to run our own infrastructure.
As one does, yeah.
As one does. I mean, if you're gonna Jenkins hard, right? So this is our actual live Jenkins instance. If you go to CI Jenkins.io, you can witness all of the crazy shenanigans that the Jenkins project has running at once. But we actually, so I'll show you some of the stuff that we've got going on, like our Terraform pipeline. And this interface, this is Blue Ocean. And this is one of those sort of big jumps for the Jenkins project.
Right.
Where all of a sudden, Jenkins doesn't look like it was developed in 2006. It looks like some really thoughtful people came together and built something really, really great. And that's what Blue Ocean is. And it's just installed right next to the rest of Jenkins. So if I go, not .o, .io, very important, and not there either. Autocomplete. Like this is the traditional Jenkins interface that everybody's sort of familiar with. Blue Ocean just sits right next to that and gives you this wonderful, easy to use user experience. So I'm going to go ahead and run some of our Terraform stuff. Big fans of Terraform. I'm really looking forward to hearing Nick talk about some Terraform stuff that HashiCorp's been doing lately. But this is just going to start running, and the beautiful thing about pipeline is if I go to some of the previous runs, you can start to see how the modeling of your continuous delivery process gets very, very, I would say, beautifully visualized and understandable for everybody in that team. So it's not just about putting the Jenkins file into source code. It's got to be understandable what's running when it's actually running inside of Jenkins.
Right.
And so in this example, in our Terraform code, we have a fairly linear pipeline. It's fairly straightforward, but we have some skipped stages here, actually. We don't need to prepare every time. We plan, which is a very useful part of Terraform, where in our case, we do a whole bunch of stuff, we sort of prepare everything, and then there's a review and an apply.
Right.
And so review is skipped here.
Yeah, explain like I'm 5.
So for us, our pipeline needs to behave differently for a pull request than for production. So we want to test our infrastructure as code as often as possible. And when someone submits a pull request, we also want to be testing that.
Right.
And the nice thing about Terraform and defining some of our infrastructure as code is for a pull request, because we're just kicking out to Azure, and we can just say, give me new infrastructure in Azure, and try to provision it from scratch with Terraform. And so we'll create a whole cluster in Azure, make sure that we can run all of our configuration, and then if this goes green, if apply goes green, then everything's good.
Got you.
For production, we actually want to review. And that's not something that, there's some, I would say, zealots for what continuous delivery or continuous deployment are. For production infrastructure, especially when you're talking about a big project like Jenkins, I really feel strongly that someone should make the final call that, hey, this isn't a stupid idea, or you're not about to just delete everything that exists in Azure, because that would be most unfortunate. So what we do is we actually just skip that in this environment. So let me jump over to our production deployment environment. Another Jenkins instance off the public internet. It's got all the good stuff there. This actually just runs the deployment part of our infrastructure. And so where we had review was missing before, in this environment, we've scripted our pipeline such that we say, if we're in this special environment, if we've got these special environment variables, that means we're actually trying to do a production deployment. And what has happened on that review stage is we waited for somebody to actually click a button. And so I can go back and see that this was deployed by Olivier. And if I get this running, do a production deployment while on camera.
Please fail, I'm just kidding.
Please do not fail. But what's really cool about this is I can watch this, I can merge changes through the normal pull request flow, get those pretty well tested for dynamically deployed infrastructure. And then when it comes time for us to deploy production, we can watch Blue Ocean, see when things come out and plan, and with Terraform it's saying, are you sure you want to do this? And then someone has to say, hell yeah, I'm sure I want to do this. Let's do it live. And then that actually goes and applies that infrastructure into Azure.
So 2017.
Yeah, it's very modern. I'm very pleased with this, actually. It took Olivier and I about a week to sort of finally find the workflow that we wanted to make work, because the Jenkins project wasn't always on Azure.
Right.
We used to live in 4 different data centers with different APIs.
Wow.
And then we partnered with Microsoft, who gave us a whole bunch of Azure and said, it's a cloud, go crazy.
You're welcome.
Thank you.
Yeah,
I really appreciate it.
Yeah.
And what that forced us to do is, all of a sudden, all of our infrastructure was an API away.
Right.
And so we sort of stepped back from the way that we were doing things before and said, if we were going to automate everything from the very beginning of our infrastructure, so creating a virtual machine, creating a load balancer, all the way to provisioning an application, how are we going to actually model that?
Right.
Fortunately, it was 2016, and Jenkins Pipeline existed, and Blue Ocean existed, and Terraform existed, Kubernetes existed. Like, all the right tools were there at the same time, to where you could just make the easy choice and just bring them together, which is really cool.
That is cool. Good choice. Good choice, sir.
So this is not failing, but we're waiting for Docker Hub to pull some stuff. So
Come
let's
on,
just
Docker, you can
assume
do
that's
it.
going to complete at some point in the future. Let's see where my other stuff is going. Looks like this is also waiting for infrastructure. One of the things that has been really interesting about running our Jenkins infrastructure is we started to open up the Jenkins infrastructure to more plugin developers.
Right.
So there's over 1,000 different plugins, and so we run a Jenkins environment for over 1,000 different repositories on GitHub. And
Oh, snap.
it's, it's for you, Seth. So what makes that really challenging is we've got to dynamically and elastically allocate resources
Right.
for that environment, and developers are very impatient, myself included.
You don't say. Yeah.
One of the reasons I originally harshed on Java was it would take me like 60 seconds to run my unit tests. I'm like, I can't wait for the JVM to spin up.
Right.
I need instant feedback right now. 21st
Right now.
century developer.
Yes.
And so being able to sort of provision stuff on the fly in Azure with the Jenkins plugins that the Azure DevOps team has developed has actually been really, really helpful to open up CI/CD for this sort of broad spectrum of Jenkins developers through our Jenkins infrastructure, which is pretty cool. And there's a lot of cool stuff that team has done. Like yesterday, I flew up and Arun, who's the head of that team, was like, "Hey, did you see that managed Kubernetes service we launched?" I was like, "I was on the plane for 3 hours, dude. Are you serious?" Like I left and these tools were not there, and then I land and Arun's like, "Hey, by the way, we just solved some of your problems. You should maybe check that out."
I'm just saying, Microsoft does cool things now. So like, you heard it live. We didn't edit that. I mean, it's not a voiceover. It's true.
That is true. And it's shocking. It's genuinely, like, when I started in the open source community, Microsoft was spelled with a $ for the S and all sorts of other juvenile shit like that. And now, like, all these sort of people I respect in the open source ecosystem are like, "Yeah, I work at Microsoft now." I'm like, what?
Yeah, I know. It's crazy. I'm here.
I don't process
Jess
this.
is here. It's insane. Yeah. Who are we even?
It's a very different Microsoft.
It is.
And what's especially cool, I actually have this tab open already, is there's this team that's invested in Jenkins at Microsoft, which is pretty sweet. And so all of these cool things that are available on Azure, this team is developing integrations into Jenkins for.
Man, we're cool. We are.
Yes,
Yeah.
you're so cool.
Yeah. Yeah.
Yeah, with your super cool hat and
I
whatnot.
know. Yeah.
And so what's really exciting for me, because I run Jenkins for Jenkins people, is there's tools that have come out which I still haven't been able to integrate, which are going to make their lives and my life a lot easier, like the managed Kubernetes service. There's this integration for Azure container instances, which
Yes.
I haven't yet rolled out to production, which is really exciting. And then some of the deployment stuff is also really interesting, because the biggest challenge for a lot of people using Jenkins is that last mile sort of to production. Like, we've tested it, we've built it, we've stood it up in a QA environment. Now getting that into production safely is something that, from the Jenkins perspective, we'd like to be modeled in the pipeline, but a lot of people don't quite have the integrations there to successfully get things out to production.
Right.
And so the Azure integration with Jenkins is actually pretty promising for that too, which is exciting.
We have about 3 minutes, so I want to make sure that we cover all of the things that you want to cover, man. So like,
There are so many things.
I know.
So of all the things that we could cover, so one of the reasons I wanted to come talk about some of the infrastructure that we have for Azure, not just the plugins, which are all open source, not just Jenkins itself, which is all open source, but our infrastructure is open source. And so the way in which we use Jenkins is open source and can be copied and emulated. It's all MIT licensed. It can be
Very
pilfered
cool.
at will. But like we have, in this repository, all of our stuff is under Jenkins-infra. We have our Terraform plans. And so the way that we provision infrastructure on Azure with Terraform is open for the viewing, which is simultaneously really cool, but also terrifying.
Yeah, go break some shit, y'all. It's going to be cool.
Do not go break some shit. Please. Well, so the nice thing about working on an open source project is you have to think about that,
Right.
and that's why our pipeline doesn't do some things. And when we were working on pipeline very, very early within the project, there's some access controls and other useful things that will prevent, Joe Rando coming in on GitHub and submitting a pull request.
Or
that
Ashley
just-
McNamara. Yeah,
Same.
who can say?
Submitting a pull request that just deletes everything. Like, the nice thing about some of the underlying features in pipeline is unless you have write access to that repository, you literally cannot. But that's not enough. Like, defense in depth is very important.
Right.
So we actually run multiple Jenkins environments, and Joe Rando has no access whatsoever to what actually touches production.
Perfect. Classic Joe,
Joe Rando, he's always causing trouble.
Always.
So this is still running. We're applying some stuff. That's good. Our deploy is still going. We're waiting. Docker Hub, you are killing me.
Oh, man.
Killing me.
Man.
But one of the other things that's really exciting about this for me is there's open source communities that are now sort of springing up for infrastructure stuff.
Yes.
So it's not just the people that work on Terraform, it's the people at like the Wikimedia Foundation or Media Week, I don't remember what it is. they have open sourced a lot of their infrastructure. And there's a lot of other organizations that have open sourced their infrastructure, which is really, really exciting. So I just wanted to mention this really briefly. On opensourceinfra.org, there's a fledgling group of people that are collecting links to all of the different open source infrastructure projects. And so if you don't like what the Jenkins project is doing on Azure, or you're curious about how another project deploys onto AWS or Google Cloud, all of that stuff is becoming increasingly open sourced and sort of cross-referenced, and we're sort of stealing ideas from each other on how to support open source projects in a better way, using infrastructure as code, pipeline as code.
Sure.
The X as codes, the various ones that we have available to us now. So all of this stuff is now another way that Joe Random, Ashley McNamara can come contribute to the Jenkins project, for example.
Very cool. And so we are out of time. If people want to get in touch with you and learn more about this, how would they do that?
So the best place to really go is the Jenkins.io website.
Sure.
On Jenkins.io/participate, we have a full listing of the relevant mailing lists, the IRC channels. If you wish to contact me directly and tell me all of the terrible things about my infrastructure, Tyler@linux.com.
Perfect. And then somebody asked how they could get this sweet hat. I don't know, man. I think it's exclusive.
From your cold, dead fingers is what I heard before, right?
I will fight you, Seth.
So every year at Jenkins World, which we hosted at the end of August in San Francisco, and I think it's September 2018 in San Francisco again, next year, we have a contributor summit.
I love those.
And the contributor summit is basically where we convince CloudBees and the other conference sponsors to basically set up a big room with all the AV, food, and everything that we need, and have about 50 or 60 people talk about the future of Jenkins, what we can do better, where we're having troubles, and things like that. And this year, that hat was given to Jenkins contributors. So contributing to the Jenkins project.
Contribute or steal it.
Or steal it from me when I come to Redmond.
Yeah.
That's one option.
So thank you, Tyler. It's been very cool. We're going to go over to Seth now, who still doesn't know things.
That's right. Well, let's give them a hand first, because we want the studio audience to feel like they're doing something. Thank you for that forced clap. That's how I usually get them, my friends. I'm actually here with Matt Rock, and you work for Chef, is that right?
Yes, I do. That's
I
right.
went to a Chef Conf, probably not this one that just happened, but the one before in Austin, and I remember that there was a new thing called Habitat, and I'll tell you just a short story, because I know your demo's good. There was a hat that they gave out, and mine was too small. And in the spirit of open source, I went into a cab with this dude, and he said, well, Seth, my hat is too large. And so we swapped in the spirit of a cooperation. But during that whole time, I feel like I didn't really understand what Habitat was, even though I had the sweet hat, which I still wear when I do garden work. So why don't you help us out, my friend?
So what did you swap it with? So you had a hat.
I had a smaller hat, and he had a larger Habitat hat. And so we swapped it, right? And so it was a very special moment, and after that we hugged for a while. It was awkward for him.
That's nice. Yeah, that's
So tell us about Habitat, because I felt like it was a container, but it wasn't. But it was more like an environment, but not that. I feel like it's a very, like things that I don't understand quite yet, I feel like they're super powerful if I just understand a little bit more. So Matt Rock is going to help us out a little bit by showing us how to modernize our Java development workflow with Habitat. Take it away, my friend.
Yeah. So hopefully I can fill in some of those gaps for you. So yeah, what we're going to do today is I'm going to show you. I'm going to basically give you a tour and go kind of through the Habitat ecosystem and show you how we're going to modernize kind of your everyday development workflow, deployment workflow using Habitat. So real quick before I kind of dive in. So my intent today is to give you that overview, to kind of give you that guided tour and show you what that workflow is like. But I'm not going to necessarily dive into all of the nooks and crannies of Habitat, which there are many. And so if you're watching this, or if anybody out there is watching this, God, I hope people out there are watching this. But
well, my mom is on for sure.
Yeah. So, if you have questions, or there are, we have Gitter and Twitter and all that stuff. But things, if you light bulbs pop up in your head, and you want to dive more into the details, so at www.habitat.sh, we've got all sorts of documentation. We have tutorials that you can go through. We also have a Slack channel, so that's a great place to go if you want real-time answers to your questions, and that is heavily watched by actual Habitat core maintainers, so good chance you'll get a timely response there. Everything I'm going to show here today is on GitHub. We've heard about that, and most of us know about that. It's in my org, MROC. The name of the repo is national-parks. So Automate, as you mentioned, it's brought to you by Chef. And we're not going to talk a whole lot about the actual Chef client today, but I do want to mention that we now have a presence on the Azure Marketplace. So if you want to check out Chef, if you want to set up automatic deployment of your infrastructure, of your nodes on Azure, totally check out tinyurl.com/automate Azure, and you'll get all sorts of information about that. So that's about all I'm going to say about Chef. A lot of people know about Chef. They know that Chef is a great tool for automating your infrastructure. The thing that really differentiates Habitat from Chef is where Chef, the center of automation is the servers, the node. We're known as the people that kind of take your server from nothing to what you want it to be. Habitat focuses on the application. So what Habitat is about is providing an environment, a habitat, if you will, for building your application, packaging your application, deploying that package to a centralized repository, and then having actual, what we call Habitat supervisors. So these are your application servers that are actually running your application, consume that depot, and run your application. So we go all the way from building your application to monitoring your application. So it's a habitat for that whole application lifecycle. And so I'm sure there's a lot of questions there.
Yeah.
And what we're going to do is we're just going to do it.
Let's do it.
Yeah, so...
and if you saw me awkwardly pointing everybody, that's because that's your camera over there.
Oh, okay.
So look at that one, because then people are like, you're not looking at me.
Okay, I'm sorry.
So everyone that saw me awkwardly point, welcome to my life. Okay.
Yeah.
Go ahead, buddy.
All right, man. So first thing we're going to do, we're going to build a Java application. It's a fairly straightforward application. It's a web app. This is going to be running on Tomcat. So a lot of Java developers should be fairly familiar with this kind of an application. And so we're going to have Habitat build this for us. And the thing that we need to do to make that happen is create a plan. So a plan is going to tell Habitat about our application, and it's going to tell Habitat how to build our application. So our plan, as you can see here in my editor, is called plan.sh. It's going to be either plan.sh, as it is here if we're targeting Linux. It could be plan.ps1 if we were on Windows. It would be PowerShell.
Right.
But the fact of the matter is a plan is shell script. So you don't have to learn another language. The chances are, if you're a developer, you know shell script. So you should be comfortable in this environment. And the plan has is usually comprised of two major sections. One is metadata, so the section at the top that basically it describes your application, and then the part at the bottom, which is essentially callbacks that you're going to implement to tell Habitat how to build your application. So if you look at some of these things at the top, we've got some basic stuff. So like name. Our application is called National-Parks. We're going to display all the national parks in the United States. Awesome. We have an origin, so you can think of this as a root of ownership. It's kind of like a GitHub organization. This is my personal origin, MROC, but this may very well be your company name. Mm-hmm. We've got version, we've got dependencies. So this is a big part of Habitat, is managing your dependencies. So. And what Habitat allows us to do is to split up our runtime dependencies from our build time dependencies. Because like a lot of us know, as developers, there's tools that we need to build our app, but then we'll never need those tools again. We're going to use Maven here, to build our WAR file, but we're not going to need, there's no need for our application servers to pull down Maven. Our application servers will absolutely need Tomcat, so that's one of our runtime dependencies. And then we have bindings. So bindings is an important concept in Habitat. I'm not going to go into all the nuts and bolts of syntax around bindings, but suffice it to say, so bindings is how services can talk and connect to one another. This is a powerful concept in Habitat. So as I mentioned, in Habitat, we have supervisors that run your application. And so a supervisor is basically a process that starts up your application and runs on a server. It can run on a container, it can run on a VM, it can run on bare metal, it doesn't matter. But the fact of the matter is, today in our, in distributed application land where we all live, I live there, I think. You live there?
I write demoware, and I've been writing demoware for the last 7 years. It's really sad. So I'm really excited. The thing I'm liking about this, as you're asking this, is that this feels a lot more than containers. Containers is an output of a process. This is more a description of both a pre and a post process.
Absolutely, and this is as we're going to see later in the demo, this is going to set us up really great for containers. So what I'm getting at with the binding is that in a distributed application, the application is not the application itself. If we were to just build this application, we would be very disappointed. I couldn't call it national parks because there would be no national parks. There would be no parks because we need a database. We need something. So we're going to need to bind to a database service. Furthermore, this application is going to take off like wildfire because,
of course.
National parks.
Yeah.
But so I'm expecting a lot of traffic, and I can't just run this on one node. So I'm going to have a few nodes in Azure running this application. So I'm going to need a load balancer, another service. So we're going to be using HA proxy, and HA proxy is going to need to be able to bind to us to be able to load us into its configuration, so it can be my front endpoint to hit, and then it'll fan out to my application servers. So all that is going to work together in Habitat, and we'll see how that works. And that's what bindings provide. Bindings provide a way for supervisors to expose configuration data about the services that they're running so that those services can discover one another and connect and interact with one another.
Got it.
So now we'll skip down to the callbacks. Again, there's a variety of callbacks that you can implement. This is a fairly straightforward one. We're only implementing a few. But suffice it to say that this is going to tell Habitat how to build your application. Habitat is basically technology agnostic. So Habitat was written in Rust, but it can build any kind of application, but it doesn't know anything about Java. It doesn't know anything about Ruby, about Node, about C#. But we know about that. The developer of this application you certainly know how to build your own application. So this is your opportunity, an opportunity which I suggest you take, because otherwise not a whole lot's going to happen, to tell Habitat how to build this. So we can see, for example, here when we do in the do build, we're going to call MVN package. And because I've declared Maven as a build time dependency, I know that Maven's going to be on my path, and I can use that tool to package up my WAR file. So when Habitat is all done with this plan file, what it will do is it will drop what we call a heart file, an immutable artifact, our package, that contains all the artifacts, in our case a WAR file, that your application needs to run. So this is a WAR file. If it was this a C# app, it might be your DLLs, your XEs. If it was Ruby, it would be your gems. So all that, all those raw artifacts, plus the descriptive information. For example, it's going to have your dependencies and their dependencies, the exact versions that you built against, which is important because what that means is that when I build this application, so we trust that all of my dependencies are Habitat packages as well. And Habitat will allow us to basically dynamically link against all of those libraries inside of the Habitat environment. And so what that means is what we build with is what we run with, and that's super important.
Well, it's also frustrating, right? Because how am I going to say it worked on my machine?
Exactly.
Yeah,
that's the quintessential scenario right there that we try to.
Yeah, I'm not going to be able to get out of it not working. Is that what you're saying, Matt? I hear you now, buddy.
So let's actually do it.
All
Let's build this application. So there's a couple ways that we could build the application. One way, what we're going to do today, is to build it actually locally. What we could do, so a couple weeks ago we launched a new service called Builder. It's basically a hosted build service where we can actually watch your GitHub repo. We can watch pushes coming into your GitHub repo. So as your application changes, we can actually build your application for you. We can take your application, package it up. We'll upload those packages to a depot where your supervisors can automatically consume those packages. So it fits great into your CI/CD solution. But what we're going to do is we're going to just build it right here, because this is what I'm trying to lead you through here is the developer workflow. And so we're developing this application version 6.2. So let's build this. And real quick, so a little word about this environment that I'm in over here. So this over here, this is what we call the Habitat Studio. And this is a special environment, so depending on what platform you're on, so I'm on Windows, but it'd be the same if you were on a Mac. When you enter a studio, we basically spin up a Docker container that includes in it a very small Linux distro, very minimal, that has a running Habitat supervisor and Habitat build system. So this is where I can test building my application and then I'll be able to actually test running the application. And what's key is you can think of this as a clean room. So as I mentioned, the Linux distro is super small. So there is a very small path, very little in your user bin. So the idea is that any dependencies and any tools that I need access to are going to be exposed to me as actual Habitat packages. And again, that enforces the guarantee that what I build with is going to be what I run with. I don't have to risk building this and having it linked to some other glibc off in the distance, and then I port this to my live environment, and I get the spontaneous combustion effect.
And we can spare ourselves the embarrassment of it like crashing a build or something, because you can run it in a clean room environment on your local machine. And everybody knows after 6 months your machine is like, you've installed too many things and things get weird. And so having like this really cool local clean environment is pretty powerful.
Oh, totally. Yeah. So let's do it. So I'm going to type build habitat. And what this is going to do, this is going to look for a file called plan.sh inside the Habitat folder. And so when I entered into this studio, it mounted the directory that I entered the studio from into this source directory in the container. So what that means is this directory over here in my editor is mounted over in the container. And so what's cool about that is if I made a mistake here, or if things change, I want to change stuff, I can change things over here and they'll be automatically manifested over here. So
and these builds are happening when it says installing JDK or whatever, it's installing it on that container.
Exactly. That's correct. Right. So we saw the Maven output, and okay, so it's finished. So now we have a heart file, our artifact. It drops that in the results folder. So let's take a look at that. Lots of builds. I've done this quite a few times. Mm-hmm. This is the one we're interested in, 6.2. I'm going to just copy that.
Yeah, that's the one I was going to say looked good.
Oh yeah, it's gonna be so much better than 6.1.
I know, that's a good one.
6.1. So at any rate, so now what we're gonna do is we're gonna run this locally. Let's see how this all worked out. So we do have a running supervisor here. Let's see what that supervisor is doing. Let's type habsup status. What you up to, supervisor?
I thought it was like sup, what's up?
It was sup.
Hab. I feel like that's what you should have gone with.
Yeah, that's strategic thing. But so I do have this tells me I do have a service running. I have my MongoDB service currently running in the supervisor. That alone isn't going to do a whole lot for me. So let me go ahead and start the application I just built. So not only does it drop this heart file, but it also installs the heart file, installs the package into the local Habitat environment. And what that means is I can do this, so I can say hab start. hey, Habitat, start my application, mroc/national parks, and it passes this bind argument. So this bind speaks again to the binding we talked about earlier. It's going to say, we're saying, hey, that database binding we talked about in our plan that is expecting to have a port property exposed to it. Well, you can find this right here is saying, well, you can find something that fulfills that contract in this service, this np-mongodb service, which is the service that's running. So I'm going to hit enter, and I don't get a whole lot back. It basically says, thank you very much, supervisor started your application. If I want to see more, I can type soup-log, which is essentially going to follow the tail of the supervisor log. Sup, log?
Yeah, that's right.
And so I see some Java-y, Tomcat-y stuff. I know things are happening, but let's absolutely make sure things are happening. So this is the glory of that is the National Parks application. This isn't running on Azure, actually. So this is my HA proxy endpoint. So let's change this to localhost and see if 6.2
Just to
comes
keep
up.
us honest.
That's right. And there we go. So 6.2, I have national parks, which is great. So the system works. So that's the develop workflow. So now let's say, hey, my development workflow looks great on my machine. Let's push this off to Azure. So here is my Azure portal, but the VMs that I have in Azure. I've got 3 application servers. So these 3 servers have 1, 2, and 3 are running Tomcat.
Those are good names.
I thought so. Yeah, thanks. Have Mongo. That is running a supervisor that's hosting my my database. And Have HA is another supervisor, another VM with a supervisor running HA proxy that's load balancing Have 1, 2, and 3. So port 8080, which is what Tomcat runs on, is not exposed. I can't hit that on 1, 2, and 3, but I can hit that here on my HA proxy, which is load balancing these guys. So if I go over here, let's go back, and I'm going to refresh just to make sure it really is running 6.1. So this is old 6.1.
Not the good one.
No.
We decided.
So what we want to do is we want to. I have Have 1, 2, and 3 specially configured with what we call an update strategy. And that update strategy is called rolling. And what that means is these 3 nodes, these Have 1, 2, and 3, have elected amongst themselves what we call an update leader. And so that update leader is right now watching the Habitat depot and looking for updated packages.
Which is those heart files.
Exactly,
Got it.
right. So if that update leader sees an updated package, what that leader is going to do is it's going to have each of its followers, one by one, update themselves, and then it will update itself. And so the power of that is that we can in real time update our application node by node, and not all at the same time, because if they all update themselves at the same time, they all go down at the same time.
Chaos and
outage,
cats and dogs living together.
So this is going to be a no tiers deployment, so let's do this. So the first thing we need to do is actually upload our heart file, and because I put it in my clipboard, I can just paste it in. So I'm going to delete that.
Yeah, we want the good one.
Totally. Okay, so it's uploaded to the depot. And now let's actually look over here. So here I have, so these 3 guys, bam, 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 are Have 1, 2, and 3. And so they're actually watching the depot once a minute. So really it's going to depend on
So should we just awkwardly stare at each other for a minute?
Right.
I think that'd make for good television.
Yeah. Look into our
look deeply into my eyes.
So there we go. Okay, so updates are happening.
Dang,
so we're moving. And once all these guys are done moving, I'm going to expect to see 6.2. So let's queue that up. Over here. So I'm going to hit the refresh.
And again, this is hitting the load balancer. Look at that.
That's right. Yeah. So I'm hitting the load balancer. So the load balance is balancing those 3 nodes. And 6.2. Yeah. This is so much better, right?
I feel like they are better. Yeah.
Yeah. So awesome. So now in the real world, typically you're not going to be deploying from your laptop to production.
I mean, we shouldn't.
We should.
But
yeah,
some people live on the edge.
That's true. Yeah. I mean, I've been guilty of that. But at any rate, this is a perfect world that we're living in right here. And so what we can do, we can pretend that these were actually my staging nodes. And in Habitat we have this concept of channels. And so we have an unstable channel and we could have a stable channel. So right now I actually have these nodes specially configured to watch the unstable channel, which is where things go when you first push them to the depot. But if I felt good about this, I could run a single command that basically just promotes them to the stable channel, and then my production servers would be watching that channel, which is what they watch by default. So that's great. I see my stuff in Azure. So now let's talk containerization. We're probably running low on time.
No, we got 5 minutes. Man.
Okay, awesome. Well, the beauty is that there's actually not a whole lot to say because Habitat has already set us up great for containerization. Because
so we will have time to stare at each other.
yeah,
Nice.
yeah. Oh, I've made time.
Yeah, we've made time.
Yeah,
For
that's definitely been a goal today.
Cool.
So because in Habitat we have this great kind of isolated environment, with portability, it makes it easy for us to convert our application over to a container. And so Habitat makes that super easy. There's really just, with a single command called export, I can export any package and export it to a variety of different formats, one of which is a Docker image. And so what happens when we do that is basically it starts up basically a bottom layer, again, that small Linux distribution that we saw in the studio, super small, and then it adds to that the Habitat supervisor. So I've got all the Habitat stuff that I need to run Habitat and anything in Habitat. And then it takes my package along with all of its dependencies and all of their dependencies. So the entire dependency tree takes all of those packages and adds that to the image. So in the end, I have this image that can run, that has everything it needs to run. And so if we go back to Azure, so this guy down here, this bottom right-hand one, this is a Docker host that I have running in Azure. And let's do a Docker PS, see what's going on. Probably the last time, same thing that happened the last time I hit Docker PS. So it's running a container, a single container, my MongoDB. So I exported my MongoDB package. But again, that container is not going to do me a whole lot. So let's start up our national parks container, which I've previously, it's like a cooking show,
Yeah, of course.
I previously created an image out of that. And let me also, just to back up real quick, what's cool is, so that builder service I mentioned, not only will it build your stuff for you, not only will it upload the heart files to the depot, but you can also configure it to then export your package to a Docker image and upload that to your Docker Hub registry.
We literally don't
So
have
that's
to
pretty
work
cool.
anymore, it feels like. This
Right,
is
yeah,
just
exactly.
amazing.
Yeah, the robots
Yeah.
have won. So at any rate, so here, if you're familiar with Docker, you're probably familiar with Docker Run. So no magic here. I'm forwarding port 8080, which is what Tomcat's running on. My image name is basically the same as my application name, National Parks. And then all the other arguments are just forwarded on to the supervisor that's going to be running inside of that container. We've already seen the bind argument, so I won't really cover that. But the peer, so this is how supervisors talk to other supervisors. So we saw locally inside that studio environment, we saw two services, but they were running inside the same supervisor. So we didn't need this peer parameter. But you could conceivably have what we call a ring of supervisors. So when you have supervisors that are connected to one another, that's called a ring. And there could be hundreds, thousands of supervisors.
We
in
call it
that
overhead
ring.
here at Microsoft. That's a joke. That's a joke. Sorry, boss. Go ahead. I'm sorry. We had an extra 20 seconds. I wanted to.
Yeah, glad we got that. So it's good stuff. So so you could have all these supervisors running in this ring. So somehow I want, right now I am nothing. But I want to start up a supervisor. I want to join that ring. All I need to do is give it the IP address or host name of one member, one peer of that ring, and then it'll start gossiping among that ring and join that ring. Now, in this case, I only have one peer, so it's going to be pretty easy which IP address I choose. 172.17.02, that is, I just so happen to know, because I know these things.
Sure.
But, that's what the MongoDB container is running as. So if I'm going to run this, so what this is going to do, so now this supervisor is starting up, and we see some Tomcat action going on with our war file. And so now, let's go over to this other tab. So it was broken. So this is now I'm hitting my Docker host. Now this is 5.6.
Yeah,
this is like
it's the ugly one.
Yeah, but like I said, that builder, our builder service can automatically upload. So if I were to push this to GitHub, we would see the builder service actually start to kick in and build this. Then I could just do a Docker pull and I could get 6.2.
So I'm starting to understand now, because Habitat not only describes your application in terms of what it needs, it also describes your application in terms of how it runs and how it builds. Aside from that, the output of that is this heart file, which I'm assuming is a Habitat runtime file, that tells you all about not only what you're running, but how you're running it. And because it's so self-contained, you can take that and put it into a Docker container or put it into some other whiz-bang G, which is going to come out sometime next year.
Exactly. Yeah, it's very yeah. You can put a container, a VM. I mean, you could have supervisors running Windows, supervisors running Linux, talking to one another. Pretty soon you've got cats and dogs living together, and it just gets crazy. But
you know what? I mean, this is amazing, Matt. This is really cool. I feel like I'm starting to understand Habitat a little bit better, and it's because it feels like containerization, while it is something that can be part of Habitat, it's definitely not the entire story. Yep. Where can people go to find out more about this before we close up?
Yeah, so as I mentioned earlier, and here's the slide again, so habitat.sh, that's going to have all of our documentation. It's going to have tutorials. It's going to have a link to that builder service that I mentioned before, which is totally free. I want to make sure I got that out there. Then Slack is very active. So if you have questions you want to ask in real time, if you're hitting a wall, if something doesn't make sense or something just seems broken, it's a good chance, well, not a good chance, there's a chance that it is broken. And there are people standing by that that can fix it. So it wouldn't be the first time that somebody's reported a bug there, but we can get stuff fixed very quickly. But more importantly, we can communicate concepts and get you on the right track. And that's the place to go.
Well, thanks so much, Matt. This has been very instructive. We've been learning about Habitat, how to modernize your workflow. We had a Java app, but as you can see, this is agnostic to types of applications, even dependency, even everything. Thanks so much for spending some time with us.
A pleasure.
We're going to give you a little bit of a hand, and we're going to toss it over to Ashley.
Thanks so much.
She's got another guest.
Hi, I'm here with Nick Jackson. And we are going to talk about Terraform in Azure today. And I am also, again, standing on a box while Seth gets a chair. So all I'm saying...
It's unfair.
It's unfair. It's, you heard it here. Nick is going to show us some really cool things. And he says his demo cannot fail.
I said it might work.
Oh, okay. That's very different. Also, he can't code and smile at the same time. I've also been told, so...
Yeah, so if I look angry, it's not because I'm angry, it's because I'm not very good at multitasking.
Literally never been angry.
Ever.
All right, let's do this, man.
Awesome.
Oh, one more thing. I want to point out for Tyler, who's sitting in the other room, that Nick has some Go stickers on here. There's another Go developer in the room. Tyler.
Yeah, Go's awesome. Everybody should learn Go.
Truth.
So what we're going to do is have a look at a little demo of Terraform and how we can use Terraform to create a Kubernetes cluster and deploy something to Kubernetes.
Oh, but wait. What's Terraform?
Terraform's like an amazing thing, and it's glad you asked because I've got some slides about that. I do.
So are they corporate slides? I can't wait.
They're the thing that pay my wages. So these are. So I think that it's interesting, right? Because HashiCorp is pretty well known for its product. So we've got like Vagrant is one of the things that most people started using.
Sure.
And then we kind of build out that with Packer and Console and Nomad and Vault and Terraform. But the company was actually founded back in 2012 by Mitchell and Armin. And the concept was that they were looking at the market and thinking there's got to be a better way to be dealing with the problems that we're now facing, which is kind of more distributed systems, moving to cloud-based, but even potentially kind of looking at like cloud migration and all sorts of things like that. So a lot of people kind of associate or know the names of the products, don't actually realize that they're all managed by HashiCorp. So there's two problems that we kind of see, and that is that, like, these two problems are not mutually exclusive.
Right.
So you've got organizations who want to be able to manage and migrate some of their applications to the cloud. But then there's also the other problem, which is application developers are getting a lot of pressure to deliver faster and deliver with higher quality. So the tooling tries to cover both of these areas. So we have like the things like Terraform, which allow you to do that lift and shift, where you can move your infrastructure over to cloud, where you can define it in a very sort of declarative way. So it's reproducible. You can put it into source control and versioning, which is all like awesome because it's a method that developers have been used to for a long, long time with our source code, right?
Right.
And it's also about adopting DevOps. So it's about getting operations and developers to work together to solve the problems that we all have. I mean, like, infrastructure is not just an operations problem. It's something that we all share. So
That sounds like magic,
it's
right? What you just said.
it's magic.
It is?
No,
Okay.
no, it's declarative magic. So it's reproducible. It's
Perfect.
It's awesome. So onto that like kind of that cloud adoption thing, you've got your traditional data center, and then that's kind of made up with your application servers, maybe your databases, your networking, and stuff like that. And what people kind of want to start doing is taking this core infrastructure, taking the application platform and the security, and security in a sort of the private data center is more often than not, it's kind of thinking about things just like a firewall.
Right.
But you then sort of start to try and migrate that over into the cloud. And the first place that most people look at is infrastructure. So that's kind of like the first layer to kind of tackle the problem. And then once you've got your infrastructure in place, you start asking, like, well, how do I start running these applications? And these can be a combination of modern applications. So it can be things like Dockerized or containerized microservices, but more often than not as well, you're dealing with kind of legacy applications. So some of the things that we just sort of seen with Habitat and like a lot of Java-based applications, you need to figure out how you're going to get that to run on your modern.
I think you got your clouds mixed up here. I think Azure is supposed to be before AWS. I'm just saying that, if you were to redo this slide, Azure Cloud should be before AWS.
I think we just did it alphabetically.
Oh, okay.
Yeah.
Okay, we're
No,
good.
we
We're
don't-
good. No beef. We're good.
So then, I've lost my place now. I completely lost track of where I was. So we start putting the applications in place. And then the next thing people start looking at is, it's like, well, the old concept of just having this perimeter security, this firewall is not really good enough anymore. So have to start thinking about how we can have a more modern sort of approach to security on our new systems. So we kind of try to break this down into these sort of three areas, which is run for your applications, secure for your infrastructure and your applications, and then provisioning, which is like Terraform, and we're going to look at today.
So the security layer there, can we talk about that for a second? Because security is very important, and I think that many companies have different definitions of security.
Yeah.
So if you wanted to like dive into that a little bit, what that means to you guys at HashiCorp.
So I think for us, it means like zero trust. So it's sort of looking at everything as a potential threat and trying to deal with that on a very sort of micro level, as opposed to just sort of wrapping everything up in this perimeter security, because I think one of the things that we see from a lot of the recent attacks that come out is that perimeter security is not good enough. I mean, people will find exploits in application frameworks, and then they'll use that to be able to bypass your perimeter security and get inside of your sort of clusters and networks. And once they're inside, if you don't think about how you're securing things like secrets, passwords, database credentials, access, running things like TLS between your services, then it just makes it very, very easy for that potential attacker to then like exploit anything that's going on there. So it's interesting you say that, because we've got a really great product which deals with security as well. But
Your soothing British accent makes me believe everything that you say, so
it's absolutely true.
yeah.
In addition to that, though, what you also have is a necessity for being able to connect all of these parts together. So generally the first problem that people find out when they start working with microservices is, well, how do these things talk together? So like communication's easy enough. You can just use HTTP or TCP, but how do you do service discovery? How does one application know the location of another one in this kind of dynamically shifting environment? So the kind of the connect layer where you can provide that capability is incredibly important, which is where we kind of bring it down to the open source products, which is for Run, there's Nomad, which is a scheduler like Kubernetes. You
Right.
have Vault to manage your security, so all of the things like TLS, secrets, and all of that sort of great stuff. And Terraform, of course, for provisioning that infrastructure, which is the thing we're going to look at today. But then you have Console, which kind of sits as that fourth layer and can manage things like your service discovery, configuration management, and stuff like that. And in addition to the sort of the open source tooling, we also offer the enterprise, which has additional features, so like Terraform, workflow management,
Sure.
and replication, and high availability, which go beyond the open source. And that's the end of the
That's the end of our slideshow. Does
the
that
end
mean
of the
demo?
slides. It's demo
that's,
time.
That's cool. All right, let's do it.
All right. So what we're going to have a look at is building up some configuration in Terraform to create a Kubernetes cluster in Azure. So what I'm going to try and go through and explain the kind of the concepts and the bits and pieces. So if there's like anything, just like stop me and
Oh, we cannot see your
oh, you can't see my
sir.
demo. That's okay, because that
live
means
is cool.
it's probably going to work better if you can't see it.
Exit out of PowerPoint is what they. Oh, look it. It's right there. How about that?
It's been there all the time.
Good job. Yeah,
So
been there the whole time.
So the first element that I want to kind of add is a thing called remote state, and state's really, really important in Terraform, because your configuration defines what will be, whereas the state defines what is. So then obviously the difference between that is what's going to happen. So managing state is really important, and you kind of don't want it lying around on a computer. You kind of want to put it somewhere safely, and I think remote state is an excellent way to kind of do that. So we're gonna use some container blob storage in Azure to manage our state, and we can do that just by adding this configuration block here.
That looks easy enough.
It's super easy, cut and paste straight from the documentation. And then the next thing we want to add is the provider. So the provider defines the kind of the top level. So you have a provider, in this instance it's Azure RM for
Sure.
the Azure API. And then you have resources which kind of sit in there. So when we set up our Terraform configuration, we need to be able to set up our provider with things like the access keys and the subscription and stuff like that. So let me just quickly add those in there. And again, I can't multitask, so.
Well, luckily, nobody's looking at your face, so we're good. I mean, except for the audience, they can totally see you.
Oh, they can totally see.
Yeah.
So what I'm adding is I'm just replacing the placeholders I've got here with some variables which I've defined. And the kind of this syntax that I'm using, where I'm using the dollar and then this sort of curly bracket, is interpolation syntax. And what that allows me to do is it allows me to replace, when I run Terraform, it'll replace the contents of this dollar curly bracket with the sort of the interpolated value, which is going to be the tenant ID,
Sure.
which is variable because it's prefixed with var dot. And I'll explain a little bit more once I've kind of finished this up. But variables are super useful. I mean, they allow you to make your configuration really sort of dynamic and reusable. And I think this is kind of a key thing. You want to kind of try and make configuration reusable. You want to make it modular. So you can share it. You can kind of do that write once, use many pattern. It's the same
I
as you
like
would do
that.
with code.
Yeah.
And it also means you can just download a whole bunch of stuff from things like the Terraform module registry and Stack Overflow, and
Oh, that sounds lovely.
which is the perfect
Yeah.
development flow. So I'm using, so for example, here I got subscription ID, and
Right.
in subscription ID, I'm defining a variable. So what I've got to do to use a variable in Terraform is I've got to define those variables.
Sure.
So this is kind of like the definition. You can see on like some of them, like the SSH key public and stuff, I'm assigning a default value, but I don't have to assign a default value. What I do have to do though is that there has to be a value for this variable when I come to run my configuration. And I can kind of provide those in a number of ways. So I can inject them using the command line flags. I can provide them in a file. I can use environment variables, or I can kind of use a combination of all of the three. So it's very flexible, so that we're kind of taking into account all of the various different workflows that people want to use. So you might want to use environment variables if you're using CI, or as an organization, you may say, file-based is the best way for us.
What's best practice?
I think it depends on what you're going to be doing. So I think you've got some secrets in here. So I've got things like client ID, and I've got client secret. I don't really want that to leak, so I don't want to be committing that to a public GitHub.
Right.
So what I like to do is I like to use environment variables, and one of the sort of, there's a utility for the Mac called direnv, and what that allows me to do is it allows me to have an environment variable file per sort of directory. So every time I change into a directory, it'll set these environment variables, and I can make sure that file is emitted from GitHub. So it gives me that kind of workflow. And then when I'm running on CI, so if I'm running this job in Jenkins or something like that, then I can just provide those environment variables into the Jenkins job. Or if you're doing something more sophisticated, you could use like Vault and all sorts of stuff like that. So there's a number of ways to do it, but I think the key thing is make sure that they don't leak anywhere public. Otherwise, you can end up with a bill that you don't want to pay.
Wait, what if you're a silly Windows user?
You could probably use some stuff. Are you like I'm? Well, you can still use environment variables.
You can do
You
that.
can do stuff. I think it's a great opportunity when we're talking about open source.
Yeah.
So if direnv doesn't work on Windows, then it's a great opportunity for everybody out there to go out and port it to Windows,
go
right?
build it.
Yeah, and maybe write it in Go as well, because then it's
yes.
totally cross-platform.
Yes. There you go, Tyler. JK, love you, Tyler.
So that's kind of our top level. But what we want to do is go and create some resources. So the just, sorry, go. This multitasking is really difficult.
Yeah, I get you.
So then I need to create well, I don't need to create, I'm going to create a resource group, and that's going to give me that top level for the various different bits and pieces that I'm going to create in Azure. And
You keep saying I don't need to do something, but I'm going to do something.
yeah, so this might already exist. So you might already have a resource group that's provided to you by your sort of operations team or something. I don't have one, and I need one for my configuration. So
you.
I'm gonna create it here.
Yeah, because if it's optional, I'm not going to do it.
Ah,
Yeah.
so you got to do it. You need
Yeah,
one.
okay.
You do
Sure.
need one, but
All right.
yeah, you might not need to
That's clear.
create it.
All right.
Yeah. So then the syntax for a resource, and a resource is literally a resource in Azure, is that you have the keyword resource, then you have the type. So in this instance, it's Azure RM resource group, and then you have the name of the resource. Now the name is not what it'll be named in Azure. It's a name that's going to be used in Terraform so you can reference it later on. I've imagined it'll be called this default, which is an appropriate name because I literally am only going to create one resource. But naming the names do have to be unique. So if I have two resource group types, I can't have them both called default.
Sure.
Terraform will complain and say you've got to give them unique names.
That's good practice. Thanks, Terraform.
So again, we can use interpolation, and I'm gonna use the namespace as the name of my resource group, and then the location, which is the kind of the Azure location, which I think I'm using West US 2. I'm just going to specify that in there again. So again, very, very simple, just using the interpolation. This is creating this. It's very dynamic. I can provide a lot of this information at runtime. And then on to the complicated stuff, which is really not that complicated, thanks to some lovely people who've created the managed container service.
Yes.
So what we're going to do is we're going to add our Kubernetes.
Oh, wow, look at that. How about that?
And this block is pretty much literally cut and paste from the Terraform documentations. I mean, I'm not smart enough to figure this out myself, so
Sure.
I think stealing code is a much better approach to working.
Why write code that already exists?
Exactly.
Why do that?
So we can, again, just go through, fill in some of the details. So var namespace. And what did I call this? K8's cluster name. So what this is, I can actually use multiple interpolations inside. So I'm going to create my name, which is hyphenated namespace, and then the K8's cluster name.
Sure.
Location. Again, I'm just going to use my location variable. Now the resource group. So I need to provide the resource group name. And what I could do is I could hard code this, or I could literally use the same name that I used in the previous block when I created the resource group. But what I can also do is use the interpolation syntax. So I can reference the name of the resource group as, so it's the type, so it's Azure RM resource group. And then I'm going to use the name that I gave it, and I imaginately called it default.
Perfect.
And then I want to get the attribute from that resource group, which is name. And you can find all of the various attributes and the outputs and inputs on the Terraform documentation, and they do kind of loosely adhere to the Azure API if you've been using that before.
Yeah, and I want to add that the Terraform documentation is actually really great.
Yeah, it's really great.
So congratulations on that.
Thank
Great
you.
documentation is important.
I will take full credit.
As you should. Why
Yeah.
wouldn't you?
But so I think the other interesting thing about doing this interpolation in this way is that because I've referenced the name of the resource group in my interpolation syntax, I'm actually giving Terraform a hint to tell it that it needs to create the resource group resource before it goes ahead and creates the container service. So by building up your sort of configuration and using these links, Terraform's able to build a graph of all of the various different dependencies. So it knows what it can create ahead of time and what it can sort of delete and all of the various different bits and pieces like that. And then, again, I can go through, fill out all of the various different bits and pieces. I think this key data is something that's worth noting, because what I actually need to provide in the key data is the contents of my SSH public key. So in addition to sort of just using interpolation for links, I can actually use some of the inbuilt functions. So I can say I want to use the file, which is going to load the contents of the file, and then I can sort of give it the path, which I'm defining in my variables as public key. Like that. And then what that'll do is that'll, when at runtime, it'll go read the file and it'll insert the details into that attribute. And that's pretty much all you need to do to kind of set up container service. So I'm going to literally I can run Terraform plan, Terraform apply, and we'll see that up and running. So this takes about sort of 15 minutes to run, so I'm not going to do that. I've prepared one earlier.
Yes.
But what I can do is I can very, very quickly show you how we can deploy an application to Kubernetes, which again is going to mean you have to stand and watch me typing a whole bunch of stuff again.
I enjoy watching you type. I don't. I'm just kidding.
I don't think any. So again, so this is an interesting element because I said I was using remote state in the other one, which means that the state is stored in container storage.
Yes.
Now what I can do, because in my application configuration, I need some of the details from that state. So I need things like my Kubernetes certificate so that I can connect to the cluster, and I need like the address of it and things like that. Because it's remote state, I can actually read the remote state from a separate piece of configuration.
Nice.
So it gives you this like really nice ability to have like a core infrastructure and then an application infrastructure. So maybe your core operations team are going to manage your main clusters, but your application developers should be able to get on and just kind of write their own configuration to deploy to that cluster. And remote state gives you that capability. It gives you that read access, but it doesn't mean that you can kind of mutate the state. So I can't accidentally delete the core infrastructure cluster, which would be
Unfortunate, yeah. That would be
it'd be a
unfortunate.
bad thing, yeah. Wow. So then what I can quickly add is my backend, and I'm using Terraform Enterprise. So in the same way as previously, I was using container service as my backend. I'm going to use, for storing my remote state, I'm going to use Terraform Enterprise for this one. And then again, specifying the provider for Kubernetes. So this is the same as the provider for Azure. I need to give it some certain information, such as like the host, the client certificates and stuff. And I can fetch that out of the remote state. So I can use the data element, and then I can say Terraform remote state, and then the name of it. So I want core and then the element that exists in that remote state. So in this instance, it's K8's master DNS, and then exactly the same thing for the other elements. So data dot.
I'm going to let you type through this and stop bombarding you with questions for the sake of time.
Yeah, it's. I could have just cut and pasted all of this in, but then
That's my
that
favorite
would
thing
have
to
probably
do.
meant the demo would work. And everybody wants to see a failing demo. Nobody
I
wants to see a
certainly do,
working
yeah.
one.
Oh, but I do feel bad about the dead air. I do feel bad about it. I'm not going to lie. I'm not a good singer, though, you guys. So I'm not going to sing you a song.
I'll try and be as quick.
Ken wants to know if you can smile while you concentrate.
No,
No.
I can't do that.
No, absolutely cannot, Ken.
That would be multitasking.
No.
So then we create that. Then we can add our Kubernetes application. So again, I'm using Terraform to provision that. I'm going to create a pod using the Kubernetes pod resource, and this kind of loosely translates to the sort of the YAML files that you might work with if you're using kube control.
Are you missing an R in Terraform, Nick? Somewhere?
Possibly.
Yeah.
Possibly.
Computers are hard, I get it.
Hopefully it's going to tell me before I
That would be nice.
commit that. So again, filling in the things, I'm going to put the image. I'm going to use a very simple HTTP echo, which is just going to do pretty much glorified hello world.
Perfect.
And I'm going to spell that correctly. And I'm going to try and spell that correctly again. The name of it, I'm just going to call it HTTP echo. And I need to specify some arguments for the startup arguments, which is listen and what I want it to HTTP echo, which is hello.
Hello with a
Open.
W was fine too. Yeah. Put some flair on it, Nick.
Hello OpenDev. We specify the container port, and then that'll create the pod. But if I want to create the pod, I also want to expose it to the world, so I need to create a Kubernetes service.
Sure, you might want to check in remote state for that extra R.
Oh, I'm going to check that.
All right, cool.
Yeah.
I'm worried about the R.
It'll. So we're gonna. Whoops. Again, we're just going to create a service. Fill in the namespace. And then the application link. And again, this is using the interpolation syntax. So I can specify Kubernetes pod.app.
What snippet manager are you using?
I use Alfred, which is pretty awesome because I've got the memory of a goldfish, which means that I just can't
same.
remember a single thing. So that's all done there. Very, very finally, let's add a DNS entry record, and I'm going to use multi-provider, so I'm going to use simple DNS simple to be able to do my DNS records.
They have some of the best stickers. I just want to shout out to Simple.
They like I don't own any of those. So they, if
they're
they want to
so
send me a
good.
care package, I'd be.
They're so good.
So DNS, TLD, and the app link, which again is going to be a link to Kubernetes. So it's going to be Kubernetes
I think
service.
they should change it to a Z.
It should just be all changed to K8, so I don't have to type as much. Load balancer ingress. And I want the first IP address.
You might want
from
to
that.
check balancers.
Yeah, totally.
Yeah.
Okay, something like that. And then let's see, where did I spell that? Terraform wrong?
No.
Oh, there. There we go. Oh,
You're not helping.
I'm not.
Okay. Oh, there's that R. Oh, thank goodness.
So then, now I've got that done, I can just do a quick check. So I'll run a Terraform plan. And that says it's going to go away and it'll create three resources, which is cool, but I don't want to run this from my local machine, so I'm going to add this to GitHub,
As one does, yes.
and I'm going to push it, and I'm going to let Terraform Enterprise do all of the planning and applying from my central location, updated stuff, because cohesive commit messages are important.
I agree.
And then I'll push that.
Is it gonna work?
That is the question.
Look at that. Look at that. It's in the dashboard and
So
everything.
then that's picked up. So it's running. It's also telling me that we've got a brand new version of Terraform, 10.8, which literally must have just been released this morning,
Oh, what a coincidence, Nick.
which will be amazing because I've now got something to blame. So you can see that, again, it was the same thing that I ran last time. So the plan, I can see that in here. Now the workflow of kind of TFE allows me as a developer to push that. Somebody can validate, and then I can just kind of say, okay, looks good. Hit confirm and apply, and then Terraform's going to go away and it will provision that pod in Kubernetes. Fingers crossed, pray to the demo gods. And this is going to take a couple of minutes. So
Perfect.
I don't have any, I'm not very good at singing either.
Yeah, you're not very good at singing either. I agree with that. So what about okay, so we talked a bit about Terraform Enterprise. Can we dive into the details for the poor people like me
Yeah.
who don't want to use the enterprise version because they want to be with the people?
Yeah, so actually the Terraform commands and all of the configuration that I ran is part of the open source. All that Enterprise does is adds an additional sort of workflow layer. I mean, if you're not an enterprise, then open source is probably more than good enough. And you can still kind of use open source with things like Jenkins and GitHub pull flows and stuff like that. So you can get all of those features. I'm literally just showing TFE because I was too lazy to set up a Jenkins server this weekend. But we don't in any way kind of cripple Terraform or any of our open source products,
I
which
love
kind
that.
of force people to upgrade.
Yes.
The capabilities are there. Generally, if you are an enterprise, then you probably need those extra things, and then that makes it a sort of a sensible upgrade. But yeah, the basic stuff like in the open source is pretty amazing. It's no way like feature crippled or anything like that.
I love hearing that. Also at HashiConf, we talked about Terraform it being in the Azure portal.
Yes.
I saw that you had that up if you wanted to like
Yeah, so you
show
can
it real quick.
You can actually from the cloud CLI. which one should I use? I'll use Bash and Linux. I'm going to create some storage. So you can actually call Terraform based straight out of the Cloud CLI. It's Terraform's already loaded in there for you to use.
That's rad.
Yeah, it's super cool.
I mean, oh snap.
It's just initializing my account. I don't know which is. We kind of found two parallel processes which were long running, what we had to wait for.
You know, Seth, nowadays the kids say that's totes cool.
I'm old, so I was
Yeah.
going for 90s.
Yeah.
Yeah.
Yeah, you did that.
Yeah, I went there.
So what this is, because Kubernetes is going to create the load balancer in Azure, so that's going to take a little while to provision those services, but it hasn't failed yet, which is for me, and it worked.
Oh my God, it worked.
I shouldn't be surprised, should I? I'd be like, yeah, of course it worked.
No,
Be like,
I'm happy. I'm sad. I wanted it to fail.
everybody wanted it to fail.
We
And
all
look,
did.
it really works as well, because, hello, OpenDev. Oh, and I spelled OpenDev wrong.
Yeah, well, you know, you spelled a lot of things wrong today, Nick.
I'm pretty good at spelling things wrong. So that's pretty much it. That's Terraform in sort of like quick sort of 30-minute overview, but you can go ahead, you can create your managed Kubernetes service on Azure. You can write the Terraform configuration for your deploys. There's no magic. It's all declarative. You can commit everything to GitHub. Full version control. More important than version control for me is the capability of Git blame. Now, I don't advocate Git blame, but it's a thing, and it's incredibly useful. Put your config in there, and you can see who screwed up your cluster when they created bad config.
Yes. So we have about 4 minutes left. What are some great resources for people if they're just getting started? And also, I don't know, if people have been using it for a while, what are some like weird resources that maybe they don't know about?
So I think there's one of the things we announced at HashiCorp is the Terraform registry. And what we're trying to do with the Terraform registry is bring all of those community modules together. So it gives you the capability of just kind of saying, hey, I need some resources like a load balancer in Azure. So rather than write the Terraform configuration by hand, you can just leverage a module which the Microsoft engineers have written for you. And then you just load that in as a module, give you all of the various different sort of resources that go into creating a load balancer, and then you can kind of build up your infrastructure using this modular configuration. And again, because it's modular, you've got the capability that you can update modules, and you can do things like versioning modules. So it kind of it'll give you a starting point to look for things, but also it'll get you up and running super, super quick. So definitely check the registry out. I think the Terraform website itself is sort of, it's got pretty comprehensive documentation on all of the provider. And you'll actually find documentation on all, I think there's like 70 providers or something in there now.
That's extensive.
Yeah, but you'll find all of the things in there, and likewise with the sort of the registry, what you're going to find is a bunch of cheat sheets as well. So if I want to create an Azure MySQL server, chances are I could probably just cut and paste this block into my configuration, run my Terraform plan, Terraform apply, and I will have a MySQL server in Azure, which is just awesome.
That is awesome.
And I think we're occasionally we'll do webinars. I think we've got a webinar tomorrow where we're going to look at some best practices around
Cool.
Terraform.
Where can people find that? I'm sure that you'll tweet it out.
Yeah, we'll definitely be doing that. But if you go to the HashiCorp website, and we are hiring as well.
You are also hiring.
We are also hiring.
All you people in the audience, no, don't do it.
Yeah, so there's a webinar tomorrow about sort of how the best practices around collaborating on infrastructure as code. And if you hit the HashiCorp website, and then go to resources, you'll be able to find the free registration button there.
Very cool. And on the website, you guys also have a spot for use cases, right? Like,
Yeah.
very good.
Yeah, so the HashiCorp website is a kind of a link off to all of the sort of the independent sort of documentation sites for Console Nomad, Terraform, and Vault and things like that. So it's a good sort of landing page. We've also got some. I really like some of the sort of the things that we've put on. So if you're thinking about sort of adopting cloud, or if you're kind of looking at a way of sort of saying, well, hey, how do I sell DevOps? We've got a whole bunch of white papers as well that you can sort of download, rip off, and pretend it's your own information.
Yeah, no, you guys were really thoughtful with your website. Appreciate that. And we are out of time.
You have a guest, though, don't
you? Oh, we do have a guest, but
You can. It's okay. We're all friends here.
Vicky.
I want to hear what she has to say.
I do too. I felt bad for Vicky. Vicky's sitting there. Vicky also has a box.
I'm just going to
got a
awkwardly
box.
insert
Box.
myself.
Please
On this
do
box.
that.
Hey.
Hi. How's it going, Vicky? You sat over there. Well, Nick just droned on. He just took all your time. What's going on? Oh, sweet keyboard, by the way.
Thanks. You too.
I know.
Cool. What was I gonna do? Oh, yeah. So I'm just gonna show you how we use Terraform on Azure and OpenAI, and we totes use all the things that Nick just said. So
Totes. Seth.
Is that a new age thing too that I need to learn? Totes.
Yeah, totes.
Okay.
yeah. Cool. So it's not working. Okay. So quick thing about OpenAI. So we're a nonprofit research lab, and we. Oh, flip my hair. Okay.
Being live is cool.
We do a lot of basic AI research with a goal of save artificial general intelligence in mind. So, and to that end, like more concretely, we're working on a lot of different projects that we think will push us towards like different breakthroughs in AI and various fields. So one of the biggest ones that we've recently released is the game playing Dota bot, and so that is we had the bot play in like an international tournament with like pro esports players, and we won.
That's nice.
And then like some of the other ones that we've kind of talked about are robotics, and currently we're working on like manipulation, and we're also doing safety, obviously.
Yeah, all of those things are fascinating yet terrifying.
Yeah, they are. So, and then, well, on many levels. So one of the things is their demands on the infrastructure, because we have so many like projects that are so different. So one of the things is how workloads differ on scale depending on the like life cycle of the research that they're in. So when you're like a researcher starting out, you're really playing with like a couple of toy experiments, and maybe you just need like 8 or 16 cores or something.
Right.
But then going to like scaling up to play Dota, then we're going to start to talk about like tens of thousands of cores for like one single experiment.
Wow.
So the infrastructure has to be super flexible, and because the different teams are on like kind of different stage of the life cycle, then we need to make sure that if they start scaling up or maturing, we can just bring up a whole new infrastructure catered to their needs. And that's why Terraform is kind of like godsend, because we can just like, copy this module and like replace it with some different variables and just like launch a cluster in an hour.
Vicky's story is cooler than yours, Nick.
Well, I was leading up. I didn't want to.
So, okay, so I wanted to show a little bit about how we use Terraform, and we have this like central Terraform module that let's just call it like the cluster. And within this module, it like references a bunch of submodules that bring up like the network, the storage, and like all the peripheral things that you need for a Kubernetes cluster. And we actually built our Kubernetes cluster from scratch because we wanted to make sure that it's like flexible for research. And then like
Overachievers.
Well, we also just because we started using Kubernetes when like it was like kind of still a baby project, and so like all the things like weren't there, and then we just kind of kept going. So and then you can see like we use the same module but just plug in like different credentials and like different VM configurations, and we can say have like a dev cluster, a CPU only cluster, GPU, and so on. And then so now I think we regularly operate 3 to 4 clusters. And whenever there's like a deadline or whatever, we might bring up like more. And then we have so many clusters. It is great.
So many. Oh, look, the parrot. I love that parrot. Why do so many people hate that parrot? I love that parrot.
Yeah, it's all over our Slack. So
It's as it should be. Parrot's fantastic.
yeah. So let's see. Okay. So just very quickly, like this is how our Terraform module looks in our dev cluster. So we have like the Atlas or the Terraform Enterprise backend, and then we have also reference a separate Terraform project that we depend on with like our core infrastructure. And then we have the cluster module that like brings up the Kubernetes masters and like all the networking and stuff like that. And then we configure like different types of workers that we're going to use. And of course, we end with a Jenkins module.
Man,
So-
that's beautiful. Look at that.
So, okay, let's see. I hope no one's changed anything in the cluster this morning. Oh, great.
Oh,
yeah.
cool. Yeah.
Yeah, that's totally. Oh. I see what happened. I changed it.
This is how programming really works, guys.
It's like bursts of like screaming red text. in
Yeah,
your face.
yeah.
Yeah. Cool. And hopefully no one on the team is doing anything on this cluster. And great. Oh, okay. So our cluster is ready to go. And I don't have anything running right now. So yeah, I guess I can just run a thing like kind of on the toy end of the spectrum, like
Yes.
what people do on our infrastructure. So yeah, so our internal infrastructure team is very small, and that's why Terraform is great because we can like manage our infrastructure as code. And basically, anything that people bring up like manually that's not in the code is like totally cool to delete. So we just want to make sure everyone writes their infrastructure as code. And then we are like, this is like an internal product. So the researchers use our infrastructure as like a service, and then they like interact with the Kubernetes API directly. So, okay, let's see. So I'm just going to run this one experiment. It's a lot of layers.
Nice. So explain what's happening right now.
Yeah, so when we kick off the experiment, we first do Docker build and then Docker push. And most of the time, well, because most things are already cached, so that's pretty quick. And then we start, we launch jobs on Kubernetes and services, and we also bring up a tensor board so people can like in real time monitor their experiments.
Nice.
So, let's see. Okay, so we have all the things that are, okay. Yeah, we're not on 1.8 yet. So. Okay, so let's see what I can do. I just want to make sure that we can launch this quickly. This is our dev cluster, so. So hopefully things can get scheduled.
This is all very fascinating, actually.
Well, let's see why it's not scheduling right now. Of course, this happens
I
right
like
now.
it live debugging. Oh, it's my favorite. Makes me feel human, you know?
Ah, why is it pending? No. It's the worst. It's going to-
This happens to the best of us, you know?
Yeah.
It's like 90% of my life is what's happening to you right now.
Oh, great. It's creating. Cool. Okay, so it's pulling Docker image.
Come on, Docker.
Yeah.
I like how you, yeah.
Oh. Nope. It's not doing a thing.
Come on, we can do it.
Well, I figured like something like this might happen. So in the meantime, I'm like, so this is like a toy example that like usually finishes training in a couple minutes.
Yeah.
But of course, like if you let it go for hours, you're gonna get much cooler results. So for example, some of the things that you can do is like, so a lot of our experiments require like a simulator.
Yeah.
So we run like the simulation on CPU, and then we run the machine learning on the GPU, and then our Kubernetes cluster usually has like mixed VM types. So we have like a bunch of CPUs and a bunch of GPUs, and then they talk over, well, sometimes they talk over the flannel network, but sometimes that's not good enough performance, and then we go straight to the host network. But anyway, so that's kind of like a very basic setup, and then you can start doing like things like this, where like
That is
can
so
actually
cool.
do things. And Docker is still doing Docker things, so.
Come on, Docker. We're counting on you.
You should have prepared that song.
Well, yeah, no. Ugh. So if people want to find out more about this, where would they look?
So most of our things are on openai.com, or like check out our GitHub. Oh, look, it's
Oh,
like
look at
learning
it.
to walk right now. So it's not very good. It's like, so
That's how Nick was walking this
Is that
morning.
a video of me getting up this morning?
Yeah,
Oh,
yeah, we didn't want to tell you. But
yeah, weird.
Yeah.
Yeah, it's gonna do that for like a few minutes, and then it's like.
And then
oh,
and then
walk.
it's gonna
Yeah.
it's gonna learn.
Yeah.
That's really cool.
Yeah, sometimes it just looks like it's like tiptoeing. It's
Yeah.
like walking like this.
That
Yeah,
is
it's super weird.
rad.
Yeah, so all of our kind of, if you want to just like try running some of these experiments, a lot of the code is already on our GitHub, and we publish like baseline algorithms so you can just like clone it and run. And we also talk a lot about our infrastructure on our blog. So
I want this in a GIF so I can tweet it out, being like me going through life like.
oh yeah, I know we
Nice,
have
you
many.
know?
Some of them look like they're just like super drunk. And,
Reminds me of prom when I went, you know, that's what I look like
Oh,
dancing.
you went to prom? Lucky.
No, I didn't. My mom took me.
Yeah, typical. Classic Seth. His mom also drove him here. Just want you to know
True.
that.
cool.
All right, very good. That was really cool. That was much cooler than Nick. Sorry, Nick. I'm kidding. I love you, Nick. You're my favorite. I mean, Seth is my favorite, so we're going to go over to Seth.
Let's give him a hand, though. AI is fun, right? I mean, I love AI myself. It's what I actually studied when I went to online school at night.
Oh, when was that?
I also got my Jedi Master certificate at the same time. I became a
Nice.
lawyer. So I'm pretty excited here to have Christoph Worm to talk about Elastic Stack. So why don't you give me like the little 5-minute, like what is Elastic Stack, why it's important, and then what you're going to talk about it
Sure.
today.
Right, so Elastic Stack used to be known as the Elk Stack, so a lot of people still know it as the Elk Stack, and that's totally fine. The centerpiece of it is Elasticsearch, probably the most well-known piece. And it's kind of interesting that the story behind Elasticsearch. The story goes that the creator of Elasticsearch, Shai, was working in London while his wife was studying to become a chef. And he wanted to create a recipe search engine for her. And so there was no good open source tool available back then to do this thing. So he started creating something, and he called it Elasticsearch. And then other people, so it was a search engine. It was a full text, pure open source search engine, and he made it open source. He put it on GitHub. That was back in 2010, I think. And then people started using it. The community started picking it up, and one of the first bigger users of it was actually GitHub. GitHub uses it for searching through all the source code that is checked into all of the GitHub repositories, both on github.com, but then also on all GitHub Enterprise deployments. And then other people picked it up as well. It's used as the search engine behind Wikipedia, behind all of eBay, and or behind Microsoft's MSN.com. So it's used as a search engine for a lot of websites, and that's where it all started. And then people found out that a search engine is actually also a pretty good place to put your machine data, to put your logs and your metrics. A search engine is very fast, has near real-time reads, has very high volume writes. It's easy to use. It has APIs for everything, and it also scales very well. And scaling means both scaling up and scaling down. So I can run it on my laptop, and in fact I do, or I can run it on 100 machines, and then of course I can have a lot more data in it and search through a lot more data. But still, all of the things that I just said are still true. It's still very fast. It's still very real time. And so people found out that, well, you can actually also use it for something like log data. And we had the community step up, and Rashid out in Arizona created a UI on top of Elasticsearch called Kibana. And Shai saw this and thought it was really cool, and reached out to Rashid and asked him to come on board. By then, he had founded a company around it, and so Rashid agreed and came on board. And then later, Jordan down in the Bay Area created a tool for getting log data into Elasticsearch called Logstash. And he open sourced that, and then Shai and Rashid saw this and found this really interesting, and so they offered him to join the company, and he did. So kind of back to what Ashley was talking at the very beginning of today, it's like writing open source actually can get you a job, right?
Yeah, you can make your own job out of it effectively.
You can make your own job, exactly, right? So this is one of the great hiring tricks, actually. We look at contributors, and then we just offer the contributors to join, and that's how companies like ours grow. But so that then became ELK, right? Elasticsearch Logstash Kibana, that's what the acronym stands for. And then we got some other software in, and so we dropped the ELK acronym and we renamed the whole thing to Elasticsearch. But basically what it's being used, especially in the DevOps space, is for ingesting logs and ingesting metrics from just basically everything, right? Like most of the things that we've seen today, whether it's Kubernetes, whether it's resources created using Terraform or anything else, all of these servers, all of these containers, all of these VMs, all of them generate a ton of data, a ton of logs, a ton of metrics, and you need some kind of central place where you can put all of this and then look at it in just one central place. And that's basically what the Elastic Stack is about.
I see. And so I remember the ELK. I've heard about the ELK stack. I didn't know that it was the search, the logging, and the Kibana, which is the UI over it. And the interesting thing is, now that I think about it, right? Usually logs, there's just these ginormous files that you're like, hey, where do we put these? And then the IT lady is like, hey, we're running out of disk space. What do we do with this stuff? And so this is interesting because my field is machine learning, and this is the kind of data that we use to create all sorts of machine learning algorithms. And so it's good. So I would love to see how this actually works. Do you have time to do a little bit of a demo for me?
I think so, yeah. Let's do that.
So what we see here is we see Kibana, that's the UI. And this is kind of a preview, so it's version 6, which is going to be out in a few weeks, but we can already see it here. And so what we see here is what it looks like once you get the data in. So you have the data in Elasticsearch in the data store, and then you have the UI on top here, where the first thing that you see is you just see your data. You just see the raw data. So what we can see here is we just have this nice histogram at the top where we can see just the number of log events that we have over time. The data that we have in here is from our own website, elastic.co.
This is like about 6 weeks of traffic on this website, about 14.5 million hits. And so we just have all of them in here, just standard web logs. We can look at the details of one of those events. If I expand this, then we can see the different fields, the different fields that are available here. Things like the number of bytes that was being sent. We also enrich the data, so we have things like the city name and the continent that we get from the IP address. We can look up the IP address in a database, and then we know where this IP address came from. And then, of course, all kinds of other things: the remote IP address that was being used, the response code that we sent back, the URL that was being used, and we can see it in this nice table form. But what we can also do is we can also see this in just the raw JSON. Everything in the Elastic Stack, in all of these products, everything has APIs. All the APIs are REST and JSON, so it's quite easy to use as a developer.
So if you're, like, the question that I have is when I'm writing an application and I want to use the Elastic Stack, right, to do all of this stuff, is there like a special, do I have to add some extra code, or do I just use my standard logging procedures by putting things out to files? It looks like you're using Nginx here in this case.
Yeah.
Is there some special sauce that I need to make this work?
No, that's the beauty of it. So we have all these tools available that make it easy for you to use on your existing data, right? You already have the log files. All applications already log out something. Usually there's like log4j for Java applications. Other applications have their own standards. So there already are log files, and then all you have to do is you just have to configure something to pick them up, and then do maybe a little bit of like enrichment transformations, and then get it stored in Elasticsearch. But none of this requires code. All of this just requires configuration.
I see. And so as a developer, you just do whatever you do. Make sure you do a lot of logging, to make sure we know what your application, what's happening in your application, and then you can use any kind of just, hey, let's just pick these up and put them here.
Yeah, exactly. What's important though is like there's this concept of structured logging, where a lot of log data, to be honest, is just really, really unstructured. It's just a log line, and sometimes that can be problematic. Where if you have some fields in there and then a field contains something like an unescaped data structure, it's almost impossible to know like where one field ends and where another field starts. So the best thing to do is actually to log something like JSON, or maybe key value, but JSON is the best. And like structured logging, then it's really easy to get the data into anything really, and to just do interesting things with it. But anyway, so going back to the demo here, so we can look at the raw data, but we can do a bit more. So what we can, for example, do is, if we want to see everybody who has access to a certain URL, we can filter down on this URL, and I can just click here, and then it creates a filter, a global filter, and it just filters down the whole view on just requests for this specific URL. And beyond that, what I can also do is I can have a search bar at the top. Like, remember, it's a search engine, so it can do search. And I can just enter something that I want to search for. So for example, if I want to search for only requests, if I want to see only requests from, let's say, Seattle, I can just type in Seattle, hit enter, and then it filters down on that as well. And then I can just see the request from Seattle for this URL. Another interesting thing that I can look at is, let's pick just any one of these requests at random. What I can do is I can look at what we call surrounding documents. Basically, the idea here is that when you're looking at something specific, when you're trying to find something specific, you might be looking for something like an error message. Like somebody called customer support, hey, I get this problem, I get this error message on the website, what's happening there? And so the operators go, the admin goes, you all guys who are watching, you go, and you look at your logs, and you want to find the error message, so you search for the error message. But then the error message itself is just one thing. What you probably want to look at is you want to look at, okay, what happened immediately before we got this error message? What was the action? What was being done? Which user was it? Which IP address? Which service did it hit? And so we can see here the context. We can see here the log messages that were immediately before and after the specific message that we selected. And what we can do here is, if we want to, for example, filter down to a specific IP address, we can also do that. And then we can see everything that this IP address has been doing. So we can see that it requested a bunch of some blog posts and a bunch of assets, images that were probably linked to on the same page.
And this is cool because, like, as a as someone that's monitoring my website, I can actually see the paths that people go through my website. I can start to test things, and I'm assuming, and I don't know if this is true, that I could have this data queried via some other program to do additional analytics on top of that. Is that right?
Yeah, you can do that. Everything here is it's a very open system. You can just access all of the data via API. There's a query language behind it, JSON based, and we have language clients available for Java, for Python, for Ruby, for whatever you have, and you can just use that and just write your own little scripts and applications and integrate it with other things that you already have to access the data that is stored in here.
That's pretty impressive. So again, like you said, there's no real work that I have to do other than put out logs. And then what does the structuring look like? Like, let's just say I'm putting out like comma delimited files. Do I have to do some process that changes it to JSON to move it over, or will it read the CSVs?
We can read the CSVs. So we have a bunch of different input plugins for things like just standard log files, but also CSV files or XML files, or we can also read data from databases. Like if you have something in a relational database and you want to pull it out of there and get that into Elasticsearch, no problem. We can also do that.
Fantastic. So is this the all of Elastic? Is there anything else you wanted to show us?
Oh yeah, definitely.
Let's do it.
So this is just looking at the raw data, and it's one thing that's really useful and that a lot of people are doing with it. But then the other thing that you can do is you can also create something more visually. You can create visualizations and you can create dashboards. So let me just show how that works. So on the left side here, I can switch into Visualize, and then I have a bunch of visualizations already in here, but I can create a new visualization. We have a bunch of standard chart types available here, things like area charts, different bar charts, line charts, pie charts, maps, and all kinds of things. I want to keep it really simple here, so let's just create a pie chart. Let me select that. Select the data type, so I want to select my log files. And one thing that, for example, would be useful to look at is look at the proportion of successful requests versus unsuccessful requests. So look at since this is Nginx weblog data, look at the HTTP response code that we send out. So what we can do here is we can split this pie chart by an aggregation, and as an aggregation we specify a term segregation for a specific field. I believe it's called response code. Here we go. So let's split this by the response code, and then very simple. What we see here is that luckily most of our responses seem to be successful. Over 75% are just HTTP 200. That's great. But then there's the next one is actually 404. So resource was not found. So that would be something interesting to look further into, and we'll do that in a second. And then a bunch of other response codes that we use here. And what I can do now is when I'm happy with this visualization, I could save it. And then I could take several visualizations and put them on a dashboard. And I believe I have one of the dashboards open here. Here we go. So I have a dashboard that I created earlier here that shows us a bunch of different things from the data. So instead of searching for looking at a very specific thing like what we see here at the top of the dashboard, it's just aggregated views. So I can see that in total I have almost 15 million requests. I have 850,000 unique IP addresses, unique visitors on my website. I can see a map of where my requests are coming from. I can see the pie chart that I just created with the response codes. And down here, I have a bit more detailed information where I'm looking at things like which browsers and operating systems people are using. Since it's a public website, there's a lot of web crawlers and bots and things like that on there. So a lot of the operating system, we can't really make sense of that. But then we have a lot of Windows 7 users. Many of them are using Firefox. Some of them are using Chrome. Windows 10, also pretty popular, has actually more Chrome than Firefox users, different from Windows 7. Some Mac users, some Linux users. And we can see the most common URLs, the most common resources that people are accessing. And not surprisingly, it's our icon. But also, we can see some really active APIs here. In fact, it's kind of interesting that the most active API here has almost 500,000 requests. I remember it's like 14 million requests here, so that's kind of a lot of requests. And what we can do here is we could look into what this IP address is doing. So if I filter down on this, then this whole dashboard filters down to just this one IP address, apparently an IP address somewhere in France, that has been active for only some period of time that we have data for, but made a ton of requests. But then actually, interestingly, it made almost all of its requests against just root. So I don't know, it might be the world's worst web crawler or something.
Yeah, I mean, that's impressive. So as I'm looking at this, and anytime I see like a tool that has this kind of power, I always feel like we need to like step out and level up. And how do I think of, because I mean, obviously there's so much I can do. What is some thought process that needs to go into like how I set this up properly?
Yeah.
Because I feel like there's got to be some overarching principles, like some stages of thinking about these things. How would you verbalize that?
Yeah, I can give it a shot. So, I have a it's actually my job, right? Like I talk to people the whole day. Like I used to be a developer, like I think everybody who talked today, like and I used to write code the whole day, and now I say like the whole day I just communicate with people.
Sure.
And so I talked to a lot of people, especially down in the Bay Area, about this. And the way I think about these projects is I think of them in three stages. The first stage is always getting the data in, ingesting the data. And it's probably the stage that you can most easily think about. It's also the one that you can most easily quantify and kind of measure by. And it's something that a lot of project teams spend a lot of time at. How do I get the data in? Now, there's two other stages, I think. The second one would be making sense of the data. And it's actually what I've been showing here, where just looking at all of the raw data doesn't really make sense. You have 15 million requests here, and that's just a demo. In a real world deployment, you would have a lot more data in there. So you need to somehow reduce all of this data that you have to something that is meaningful to you. And so there's two ways that I've shown here of doing that. One is to filter down to something specific that you're looking for. Like the filter for the city, for the specific URL, what I showed first. And that's one way, where we're using all these different data points to just the few data points that you care about. And then the other way, what you can do is, instead of going down into the details, you can go up, which is this dashboard, where you're looking at an aggregated view of the data, but no longer at individual requests. So these are like the second step, making sense of it. And then the third step is doing something with it. Right? There's usually two ways that people do something with these insights that they found. One is that they just do something manually. You see something in the data, like here we've seen this IP address, and now we could decide what to do about it. Maybe having 500,000 requests for the same thing from one IP address doesn't really make sense, so we might decide to, for example, block it, or we might want to further investigate. So that's the more the manual way. But then you could also do something more automated. You could have the system reach out to you, for example, in form of some alerts, like you might get an email if something like this happens, or if something like else happens. You might define thresholds and things like that. So these, I think, are the three stages: getting the data in, understanding the data, building your switches, building your dashboards, and then doing something with it, like building some alerts, for example, or establishing some kind of workflows or something, of reacting to it.
So I've seen how you do the, I see how you do the understand part. The ingest part, to me, that's still, is there some process? Is this part of Elastic Cert or the Elastic stack that does the import of the data, or is there something I have to do external to that?
Yeah. Good question. So let me show an architecture slide.
Let's do it.
And we can look into that. So what I have here is I have only one slide with me here, and let's see if this advances. It does not.
You can just
here we go.
There we go.
No, here we go.
There we go. Woke up.
The MacBook Touch bar actually saved me.
Oh, wow! There's one good use for it, right?
There is, yeah. Advancing PowerPoint slides when the trackpad doesn't work. Yeah. Right. So we see the kind of the like an Azure architecture for deploying Elastic on here. So on the left side, we can see how the data gets in. Now, there's two main ways that you can get the data in. One is to use Beats. Beats is a framework that we have, a collection of different data collectors. So these are small little agents just written in Go, so don't take up a lot of resources. They would run on the actual edge machines, on the either the virtual machines, or if you have containers, in the containers, and they would collect data, mostly log files, system metrics and application metrics, but it could also be things like network packets, and you just collect this data and just send it forward. Another way of getting the data in on Azure is we have an integration with a bunch of different Azure services. if you have some files already in storage blobs, then we can get the data out of there. If you're funneling your events through something like a service bus or Azure Event Hub, then we can get it from there. Or as already mentioned, we can also just pull data directly out of databases. So this is the out-of-the-box way of getting data into Elastic. And beyond that, actually, we already talked about the APIs, right? You can also you can go out and do whatever you want on your own, right? Like if you want to get your hands dirty and actually do some development, then you can, of course, also do that. And then what we have is you collect the data first in the left part. You might have to do some kind of enrichment. For example, for like logs, you usually have to do some kind of field extraction where you just have a big log line that has multiple different fields. It has a timestamp, an IP address, a username, and some other information, and you want to extract that into its own fields. And so that is something we can do in Logstash. And then we have Elasticsearch as the data store, and we have Kibana as the UI on top, and we've already seen that one.
What about XPack? What does that do?
XPack is the commercial extension that we have on top of the open source. So unlike some other open source companies, what we do is we don't have an enterprise edition of all of our open source components. We just have the open source components. And we just continue to develop them and release new versions of them. What we have commercially instead, we have commercial extensions on top, so basically as add-ons or plugins. So the nice thing there is you can just keep your open source installation as you set it up, and then if at some point you see that you can get value out of the commercial extensions that we have, which are things like security and alerting and monitoring and reporting and machine learning and these kinds of functionalities, then you can just install them on top, drop them right in, and you're good to go.
That's awesome. The other question I have is, with the volume of data that's coming in, do you get, like, is it real-time search, or do you have to shoot off a job and then things happen? How real-time can this be?
Yeah. It's fairly real-time. Like, one of the reasons why I think this stack is so popular for especially log data and metrics is that you do need real-time access to the log data, the metrics. If something is going haywire in your anywhere in your IT landscape or any of your applications on your web servers, then you want to be able to debug now and not wait for some job to finish.
Right.
So even if you have a ton of data in here, and we have deployments of hundreds of terabytes of data, even sometimes petabytes of data, you can still expect this real-time response time. You just have to scale up your data store. Elasticsearch matters here, so instead of just having it on your laptop or on one instance, you would have dozens, maybe even hundreds of instances. But then it's perfectly possible. It's really designed to scale.
That's awesome. So you mentioned that it works on Azure. How does one set that up? Because I mean, this is a super interesting way of looking at logs.
Yeah, definitely. So what we have is, and I'm going to quickly show this here, is, let me switch back to my browser. So I have our Azure portal here that we have. And this is something that I would assume that every Azure user uses every day. And so to deploy Elastic, what you can do is we have a template. We've developed a template together with Microsoft where it's a deployment template. So it deploys a bunch of VMs and then surrounding infrastructure and configures them with Elastic, deploys Elastic on them, Elasticsearch and Kibana the UI configures them, and then you're good to go.
So it's literally just a click template and it's there.
It's basically like that. So like you just click on new, and then you can search the marketplace here. So let me search for Elastic. And when I search for Elastic, the first thing that should show up is, there we go, the official Elastic Stack template. So you just click on that. Gives you a bit of description here, and then at the bottom you can click on create, and then it takes you through this 8-step process of configuring everything. And I think I have it open here in another tab where I've already filled some things out. So you just configure things like the username and the password that you want to use to be able to access the VMs that are going to be deployed for you. You can configure how many nodes you want to have. You can configure which node size you want to use depending on how much data you expect to put in there. And then a bunch of other things, whether you want to deploy the UI. And then at the end, it gives you this nice summary that summarizes everything that you've configured. And then you just click on OK, and you after it has validated this thing, there we go, and you just click on OK now. And if I would do that, then it would now go and it would create all of the machines, then create all of the application gateways and everything that is necessary to set this whole thing up. And then essentially you just have a URL and IP address that you can go to, and then you would see the UI that I was just showing. You would see Kibana, and then there's no data in it at the beginning, but then once you get the data in, you're good to go.
that's really cool. The other thing you mentioned, and it's because I'm a machine learning guy. You said something about machine learning. Can you talk a little bit more about that?
Of course. So we have we have this functionality that we call machine learning. Now, what it does at the moment is it does anomaly detection. When you have log data or metrics, then all of this is time series data. Everything has a timestamp associated with it, and so there's probably some kind of pattern to it. There's probably your data is not different every day, but you have just about the same number of visitors on your website today that you had yesterday, than you had last week. So then that means that you can do some very nice anomaly detection on there. And I can actually show it here. I have a demo of this. Yeah.
Some machine learning robots here.
There we go. So I have the machine learning tab here, and we have a few jobs already configured, but I'm going to create a new job here. So when I create a new job, I have a couple of options for how to create it. Let's keep it very simple for now. I select my data set again, and then what I can configure here is it first asks me what I want to look at. So this is unsupervised machine learning, so I don't have to train it or anything.
Right.
But I just point it towards the metric that it should track. The easiest thing, what I always start with, is just the count. Just look at how many documents, how many events do we have here. And so if I do that, then I should be seeing here this is just an aggregation of the raw data, what we've seen before already. So just kind of like the normal up and down. And now what we're looking for here is we're looking for anomalies in this trend, in this time series. And so what I can do here is I will give it some kind of I will give it a name, and then I will hit create job. And as I hit create job, what it will start doing, it will start looking at the data as it has it and it starts creating a model based on what it sees, based on what it observes. And so it goes through and very quickly through all of the data that we have here. Remember, it's about 6 weeks worth of data, some 15 million events, something like that. And it starts building this model. And it was actually pretty fast. It's finished. It found at least one anomaly. So let's look at the result viewer. Let me actually go to the very beginning first. So here we can see the learning phase. At the beginning, when it had just started building the model, it doesn't really know what the pattern of the data is. It doesn't know, is there a daily period, is there a weekly period, what are kind of the normal ups and downs, what are the normal values for this time series. So it just kind of is very naive at the beginning. It just assumes an upper and a lower bound, and this kind of seems to work for some time. And then after a bit of time, it starts getting smarter. Like here we can see how it got smarter, how it recognized that, oh, apparently there actually is a daily period in here. Probably since it's a website, we're going to have more traffic during the daytime and less traffic during the nighttime, just based on human psychology, or us having to sleep at night, unfortunately. And so the model becomes more precise, and then at some point it found an anomaly here where we can we usually have this seems like daytime, the number of users increases, and then suddenly it drops down hard. So what we can see here at the bottom is the actual anomaly that it has found, details about it. So we found an anomaly on February 27th, and we were expecting about 4,600 requests during this time period. I think it's about a 15-minute time period here. This would have been normal. This would have been expected. But we only actually have 281, so something went wrong, right? Like it's 16 times slower. And in fact, like some people might remember this, February 27th was the day when back when AWS S3 had an outage. Like the whole thing went down, and our website was actually tied to this in some weird way in the back end. And so, as many other people as well, we had a problem.
So that's a really cool, because it takes you from getting the data in, from actually visualizing, and then to actually getting some intelligence over that data in order to act properly. Yeah. That's awesome. Well, it turns out we also have a customer here that uses it. Anshul Kumar, why don't you come on over here, bud, and have a seat, and tell us a little bit about what your company does, and as well as how you use the Elastic Stack.
Well, thanks for having me here. So I work for McKesson Corporation. We'll move to the next slide. Oh, the touch bar.
Nice.
Thanks, Christoph. So McKesson, it's not many people know the name, but it's the biggest healthcare company in the United States and more than 185 years old. And I work for the medical surgical business unit. And we have a quick map there. Those are our distribution centers that belong to my business unit. And our customers are physician offices, surgery centers. We are pretty much the middleman. So next time you see a McKesson van driving around, that's probably from one of our distribution centers, and that's our own private fleet. So Elastic Stack, I was talking to Christoph earlier, and he's like, what can you tell us about Elastic Stack architecture? And I had around 5 minutes to do it. So assuming engineers are smart people, I threw together this word cloud. So hopefully I'll try to speak to it, and people can hopefully search on it and get more details. So the first thing was bring your own license. So we have on the Azure ecosystem, you have a PaaS service, Azure Search. We did not do Azure Search because our use case is mostly about aggregate functions, and Azure Search does not give aggregate functions. So that's where we had to build it as an IaaS service. And as soon as you get into an IaaS model, then if you recall from a couple of minutes back, the Azure, like the template, the ARM template that Christoph walked to us, so that was our starting point. We deployed the first set of Elastic cluster through that template. Next thing we found out is building Elastic on-prem is very different than building Elastic Stack on VNets, right? Because Azure security, so as development group or the infrastructure team, we don't have access to tweak the private VNet on the cloud. That's done by a separate team. So it's imperative that we know about our subnets, and people who are in Azure, they know the subnet is the range. So if you think your Elastic Stack cluster, you want it to be 1,000 nodes to 100 nodes. Make sure you plan that subnet and ask the team to build you a subnet with that kind of IP space.
I see.
So, and on speaking about the IP, another thing is the security is pretty rigid. So you need to know your ports. On the Elastic Stack, 9200 through 9300, that's the basic requirement. But we got burnt on that. That's what we assumed. We built on that. Later on, we found out that the app team uses port 9500. So it's good to start a conversation with your own internal consumers. What ports are they going to hit the cluster with? Know it in advance, then later on. And one other thing that came up is we, being in healthcare, security is of utmost importance.
Of course.
And I think traditionally, our data centers are in complete lockdown. So no one gets in, no one gets out, right? So it's all easy. But on the public cloud, we had to make sure that we are only selectively opening up ports. And even within the Azure space, we have multiple VNets. Why is one VNet talking to another one? So on that side, we had to do plenty of research, and we are a big Hadoop shop. So we push data into Elastic through Hadoop,
I see.
the ES Hadoop 30. And we specifically opened only those IP addresses. Another thing that, which I can pretty much guarantee, as soon as you move from on-prem to an Azure and you try to run your Hadoop jobs, it's going to fail. And that's a highlighted red property.
Of course.
So make sure you add that ES nodes van only. What it's doing is it's making an entry on the ES nodes, and it's specifically telling the Elastic Stack traffic and the Hadoop traffic to hit only these nodes. So it's not searching for Elastic awareness all across Azure. The other problem we found out was in the existing Git template. In the PaaS model on Azure, you can scale up and scale down. And you can, when I say scaling, it's vertical and it's horizontal. Vertical is going to be bigger VM machine.
Right.
Horizontal is going to be more VM machines. And we don't have that functionality in the current world. And at the same time, if you are live, you're running a production cluster, people have tied their jobs to the load balancers, right, the static IPs. You cannot flip it on the fly. So it's imperative that you keep the same IP static. The only way we were able to find out to do this was selectively take down a machine, take out one of the machines and use the Azure Active Directory and the Azure space to insert one machine at a time. So hopefully it has the same host name and the same IP address.
I see.
And the one other problem on security is encryption at rest. So encrypting these machines takes, these are bigger machines, so it takes, don't be surprised if you're taking one full day, 24 hours, and just getting the OS part encrypted. The data it might run for 3 days. So try to put that buffer as you insert more machines and set up those expectations. And the managed cloud provider specs, so because we are a bigger enterprise, so we outsource our management of our IaaS assets on Azure, and we went with Rackspace. And earlier on, we thought, well, encryption is encryption, so we ended up doing BEK. Turns out that's not supported because the rack space backups were failing. They only support KEK. So that's another thing to set up expectations with your cloud providers. Like I said, each encryption 3 days. Better know it in advance than
Right.
later. And we do use the Azure storage, blob storage. That's for disaster recovery and like geo-replication. So in case of a DR, we can flip over the data and build a brand new cluster on the fly. And we did a drill. It takes around 60 minutes for us to go live on that.
Wow. So you actually like ran through the failure and
Yeah.
turning over, and it took 16 minutes.
We try to mimic it. Yeah.
That's amazing. I mean, this little 5-minute thing that you did is just like, look, here's some tips of, because we've used the Elastic Stack goodness. These tips and tricks, you should watch out for those. These are amazing. Any more you have in closing?
I want to do some fun stuff. The next one
Let's
that
do
I
it.
had was, so traditionally, I come from a data warehousing background, and the traditional approach on doing research or analytics is to first get the data, somehow load it into a relational database, and then try to kick off your joins and all that stuff to make sense of the data, how it connects together. And this became a challenge. Usually it's good with the little amount of data, but for projects like the Customer 360, where the data has not been looked out by anyone, this is the very first time someone's looking at it. I started running into issues where the unstructured data support does not exist. And the second thing is the field limitation. Right? It can only take 1,000 characters and so on. So then it occurred to me, how about I throw everything into Elastic Index using Hadoop? I just separate indices, super simple, just load the data as it is, do not manipulate it. And towards the end, just drag drop each one of the indices into one dashboard pane. We just drag drop it. So that's what we did. In the screenshot, most of it is masked, but if you look closer into it, the first one is coming from our IVR system. That's our call center support calls, and there's an NLP behind the scene. I won't go into that. The next one is from our Salesforce.com engine, and we are also using the Net Promoter Score in here and our e-commerce website. So essentially, with minimal development effort, I think 6 hours of coding, that's what it required. I already had a BI visual dashboard, which I was able to send to my product owner. And he says, okay, how do I search it? And like, if you can type in the text box, you can search it. So there are no joins needed, nothing. So this was a good slingshot approach we got.
And this is impressive because it's coming from like multiple data sources that are not traditionally in the same place.
Yeah, and the best thing was traditionally, IT builds a product, rolls it out, then business comes back to find out how can you validate it? It's doing the right thing.
Right.
So there's a second portion to the screen where we're exposing the complete indice. If business has a question, they can look at it because we did not throw anything out. So Elastic calls it what I'm going to call records. Elastic calls it document. The whole document is available. They can open it, click it, the entire email, and that's why it's showing up.
That's amazing. So a question coming in from the audience, are there any limitations on joins? Any guidance on making search queries not expensive from a compute perspective?
Yeah, so joins is an interesting topic. The question comes up a lot, like, does Elastic do joins? I know, like, as an architect, I should never say no, but it's kind of like no. The reason we don't do these arbitrary joins that something like a SQL database does is that, as I said, we can run on like hundreds of nodes, and doing joins, arbitrary joins across these hundreds of nodes just doesn't scale. So there's different things that you can do. One, we can do like some kind of pre-join. So what you can do is you can say when you put in 2 documents or like more documents, some set of documents into Elasticsearch, you can specify a relationship there. You can have like a parent-child relationships, and then we make sure that we store these documents all on the same machine, and then we can actually do like in-memory joins, so then it works. So that's specifying it before, or alternatively, like actually what many people are doing, like they're not even doing that. Like what you can often do is you can just denormalize the data before you get it in.
Right.
Something like a log message, like the web logs that we've seen, like an appear this is probably not just going to appear once in all your web logs, but several times. But we just store it multiple times, right? Like we're in a distributed system, we can store data, we can store a lot of data, and then of course searches are really, really fast. So there's different ways of dealing with this, but people usually find a way.
So no, but yes. No, but yes. You can do joins.
No, but yes, exactly,
no, but
right?
Yes.
Like,
no, but yes, yeah. Took a little processing time. Well, anything else? Anywhere? Where can people go to find out more? Anything else you want to say about this?
Sure, I think the easiest way to go is just go to a website, elastic.co, and we have a ton of content in there, right? We have like documentation for all of these tools. We run at least like one webinar a week, oftentimes more. We have a very, very active blog which describes all of the features. Everything that I've shown here is something that you can look up there and you can look into. And hey, like if you ever like feel that you would like some additional help, right? Like just let us know, and we're happy to help.
Awesome. Well, thanks so much for spending some time with us, Christoph and Anshul. This has been amazing. This has been a really good Azure OpenDev. This is, unfortunately, the last session. Just a couple of things to call out. All of the sessions will be recorded and available on demand, along with Getting Started tutorials and labs at azure.com/OpenDev, so make sure you do that. Continue the conversation with our speakers on Twitter using the hashtag Azure OpenDev. And finally, if you're in Seattle, join us for the Azure OpenDev after party at I can't even read, man. Hard Rock Cafe at 6 p.m. Go to aka.ms/OpenDev after party to register. It's been a joy being with all of you. Thanks so much for watching, and hopefully we'll see you at the next Microsoft Azure OpenDev. See you then.